So good morning, and this is our real pleasure to welcome and to have this event here this morning. While there are other events, I would say, in the region that create kind of a debate, a global debate, such an event like this one is deep in the consensus of the entire community of how valuable and how important is to have such discussions about the combination of several communities that decide to join together to have a discussion, and a combination of topics that start from a very technical side of the range and take it to the other social and behavioral aspects of our era. This is great to have here in Tel Aviv senior representatives from several countries that we are so happy to be together as part of the GCTF organization, and for others that join remotely or will be part of having these contents later today. We have quite a full agenda with several welcome and greetings parts, and later on two very deep sessions about important topics of the challenges of the digital era and the digital solutions for resilience and supply chain. We in our center and in our university, we are excited on one side from all the good things that come with this digital period that we are part of, but on the other side we are concerned and work a lot to learn more and to develop and to research about the threats and the challenges that comes with these good things of a digital era. So we'll try to spend some time this morning to enjoy learning and developing about these topics. So without further ado, I would like to welcome to the stage the Executive Director of our Blavatnik ICRC Center and the Cyber Center, Gili Drob-Heistein. Please.
Thank you, Yaniv. Thank you, Yaniv. Good morning, all. Good morning. It is my great pleasure to welcome you to this exciting seminar that is the result of a new collaboration that we are very pleased to be part of. As an interdisciplinary cyber research center with an interest in the digital world and fostering collaboration at the economic and society level, we are very happy to be one of the hosts of this event. This seminar came about due to an initiative from the GCTF, the Global Cooperation and Training Framework. This organization was created in 2015 and now has full partners in Taiwan, US, Japan, and Australia, aiming to collectively tackle global issues of mutual concern. But instead of me telling you all about this organization, I would like to play this short video to describe the organization that is the driver behind today's seminar.
Ladies and gentlemen, welcome to this Global Cooperation and Training Framework affiliated event. The GCTF was established in 2015. During that year, the Ebola epidemic rampaged across West Africa. Taiwan and the United States launched an Ebola training center to share our experience and expertise with professionals from Indo-Pacific countries. Following that successful project, Taiwan and the United States signed a memorandum of understanding to launch the GCTF, which has served as a platform for Taiwan to contribute its strength and expertise to address issues of global concern with like-minded partners. Over the past 6 years, The GCTF has organized more than 40 international capacity building workshops on public health, supply chains, humanitarian assistance, and other regional issues. Participants from about 100 countries have taken part in these events for the benefit of different regions across the globe. As an incubator for international cooperation, the GCTF has received wide recognition. In 2019, Japan joined as a full partner. Subsequently, Sweden, Australia, Guatemala, the Netherlands, the United Kingdom, and Slovakia have also co-hosted individual GCTF workshops.
The Japan-Taiwan Exchange Association has joined the GCTF since 2019. Taiwan is an extremely important partner and a friend to Japan, sharing fundamental values such as freedom, democracy, human rights, and the rule of law, as well as having close economic ties and people-to-people exchanges. Taiwan's response to the COVID-19 pandemic and the important role it plays in the global supply chain of semiconductors and the advancement of scientific technology have attracted a great deal of attention from the international community. It is very important for the international community to share knowledge and experiences in these areas. And I believe that the GCTF can play an important role as a platform for tackling global challenges.
Our collaboration has helped build support for Taiwan on the world stage by providing high-quality, relevant training to third country audiences. Over the past 6 years, this model has been so successful that we have expanded our joint efforts and created the GCTF franchise. This will help meet the demand from other regions of the world that want to work with Taiwan and benefit, as many have already, from the expertise and experience that Taiwan can bring to bear on so many truly global challenges.
We look forward to working with you and all of our partners around the world
as we work together to address shared challenges
and develop solutions as partners.
We have speakers from Taiwan, Israel, and the United States, and I'm sure that the talks and discussions will spark interest, ideas, and new collaborations. We really appreciate the international nature of this event, both in terms of the participants and the people who have joined us, whether they are here in person or online. Before I introduce the next speaker, I would like to mention that we are currently working towards our next big conference, AI Week, which will take place from the 13th till the 15th of February 2023. You are all invited to attend, and should you wish to take part, please get in touch. I would like to take the opportunity and thank Dania and Tal for their hard work. I would also like to thank Representative Yaping Gili, our new partner. She recently moved to the Taiwanese Economic and Cultural Office in Tel Aviv, and we can see that she's bringing a lot of energy and drive to her role. Thank you. We are looking forward to our future partnership and have been delighted to work with her and putting this seminar together. Thank you also to our partners at the American Embassy. We look forward to further collaboration in the future. Thank you to everyone who has come today and to all our speakers. Back to you, Yaniv. Thank you.
Great. Thank you, Gili. And this is our pleasure now to have Her Excellency Stephanie Hallett, the Chargé d'Affaires of the U.S. Embassy here in Israel, in Jerusalem. Please.
Thank you so much. Good morning to everyone here in the room and certainly everyone who is joining us online for the first Global Cooperation and Training Framework Workshop that's being hosted here in Israel. I'd like to thank my co-hosts for today's exciting gathering, certainly the Taipei Economic and Cultural Office, led by my new friend, Ms. Lee, and of course, the Interdisciplinary Cyber Research Center, as we all know it, ICRC, here in lovely Tel Aviv University, under the leadership of Professor Isaac Ben Israel. Thank you so much for hosting us. To the United States, we recognize ICRC as an established thought leader in the fields of artificial intelligence, cybersecurity, and digital transformation, not just here in Israel, but across the world. More than 30 representatives from my government attended the Cyber Week conference this past June that ICRC organized here. This is a sign of the high regard in which we hold ICRC and Professor Ben Israel. I also want to express my appreciation to Taiwan for co-hosting this event. Taiwan is a global leader in the realm of digital economy. The Institute for Management Development ranked Taiwan the 11th most innovative economy in the world in 2022, and number one in the number of personnel working in R&D per capita. Earlier this year, Taiwan launched its Ministry of Digital Affairs, creating a dedicated ministry to create an ecosystem to maintain Taiwan's role as a global leader. Perhaps there's no country better positioned for the digital economy of the future than where we're sitting right now in Israel, the original startup nation. Israel, as we know, regularly ranks among the top leaders in innovation, no matter how you measure that leadership rank. The number of patents, the number of Nobel Prizes, the number of companies listed on the NASDAQ stock exchange, or the number of unicorns, startups valued at over $1 billion, Israel is at or near the top of the leaderboards in all of these measures. And I would say for all of us from the US side, Israel's success is America's success as well. The United States is Israel's largest trading partner and largest investor in Israeli companies. Intel, a proud American tech company, is the largest private sector employer in Israel, which is absolutely incredible. Flights between Israel and the United States are packed with venture capitalists looking to invest in the next bright young Israelis startup. While thousands of Israelis pursue higher education in the United States and bring that knowledge back with them to build their businesses at home in Israel. Just yesterday, our embassy concluded the 15th annual Global Entrepreneurship Week, providing inspiration and networking opportunities for budding Israeli entrepreneurs. And in just a little while, my colleague from the State Department's brand new Bureau of Cybersecurity and Digital Policy, Mark Cullinane, will tell you all about that bureau's work elevating the role of digital communications in 21st century diplomacy. So how can all of the emerging leaders grow their fields? Well, for me, the answer lies in partnerships. As you advance in your studies, looking out for future partners, the co-founders of one startup, might be in this room, whether virtually or physically in this room today at this university. So be on the lookout. Again, let me thank our partners for this incredible event today, the Taipei Economic and Cultural Office, ICRC, and Tel Aviv University. And we wish everyone lots of success through this conference as you set out to make a difference in the digital economy in the days, weeks, months, and years to come. Thank you.
Thank you, Her Excellency, for the so touching, I would say, words and that really represent the close relations between our countries, and for your support for the ICRC for years activity. We're also proud of these relations. For the next speaker, it is my honor to invite Her Excellency Yaping Abili from the Taipei Economic and Cultural Office in Tel Aviv. Please welcome you. Thank you.
Chargé d'Affaires Stephanie Hallett of U.S. Embassy, Jerusalem. Director Isaac Ben Israel of Interdisciplinary Cybersecurity Research Center. Deputy Director General Lin Junshou of Ministry of Digital Affairs from Taiwan. Dear speakers, distinguished guests, and participants online and on-site, good morning. On behalf of the Taipei Economic and Cultural Office in Tel Aviv, I'm honored to welcome you in joining us in this GCTF workshop to discuss the challenges and outlooks for the digital era. I would like to thank the U.S. Embassy for your resolute support in making this event possible, and I also want to thank the ICRC to bring in such a strong panel of experts to touch upon this important topic and co-hosting the event with us. Since the launch of the Global Cooperation and Training Framework, the GCTF, in 2015, one of the core missions of the GCTF is to establish a platform to bring together a panel of thought leaders across the globe to discuss the global issues. Today's topic is also a very important agenda in global setting. We look forward to more discussions. The experts can share their strategic thinkings and innovative views with partner countries. There have been nearly 60 international workshops held since then, and with today's seminar, we think the robust discussion will definitely underway, and the enhanced cooperation in global economy will definitely enhance today's discussion. I'm pleased also would like to mention one point, that is today's GCTF seminar is the first here in the Middle East. And the digital economy is, of course, the important agenda that US, Taiwan, and Israel have been working closely together, including the Taiwan-US Economic Partnership Prosperity Dialogue and Taiwan-Israel Economic and Technological Cooperative Conference. We believe all of us have so much to offer to the international community, and Taiwan will remain committed to work with our like-minded partners and countries and to deepen our economic partnership. As we get the seminar underway, let me once again welcome all of you to join us in person and online. I wish you all an awe-inspiring and productive discussion. Thank you.
So thank you for your collaboration, and it's our honor to invite the one who initiated the ICRC about 8 years ago, right now, in something like this, and he's named as the godfather of the Israeli cyber in many aspects. So it's my pleasure to invite Professor Ben Israel, the director of the Blavatnik Center. Please.
Okay, don't have to tell you when it started. Everything started with Turing, as we all know, and actually the first computer, real computer, not a paperwork, was built by von Neumann at 45 for United States Army. And once people started to build chips from transistors, and I don't have to tell our friends from Taiwan about transistors. One of the first tools I ever made when I started diving into high-tech, before even the 90s, was a tool to fab in Taiwan to understand how it's built, so I don't have to tell you about it. But what is important, and this is important for digital economy as well, is that since the 1960 until today, we have this observation of Gordon Moore, which we call Moore's law. It's not really a law. It's an observation that every year and a half, more or less, the size, the physical size of the transistor shrinks to half or something like this. We put 2 times more transistors on a chip, and therefore we double the capacity, the power of computation. And this started happening in the 60s, and it's still going we are towards the end of this, but quantum technology will keep the pace. Now let me speak a little bit about history of cyber security from the point of view of Israel, which is an essential element of economy at all. It's not only digital economy in the narrow sense, but economy generally, I would say. Like in many countries in the world, we were started being involved in what nowadays we call cyber technology in the 80s. Simple reason, people started to store information in computers, and if you are an intelligence service, your mission in life is to get this information, put your hands on this information. You have to find a way to hack into computers to take the information out of it. Very simple. Started in many countries in the world. Israel was one of them. Then came the 90s. Moore's law is always working in the background. Computers became small enough to be put on board military platforms. So people around the world started to think, including here in Israel, started to think, maybe we should take advantage of it. If I want to protect myself against, let's say, an air attack, I can shoot the aircraft that are coming to attack me, it's still in the military organizations, okay, not by the normal civilian society. I'm speaking now the way defense organizations fought at that time. I can shoot the aircraft down, or I can jam the electronic systems, but now that there is a computer on board which controls the aircraft, I have another way of doing it, and this is hacking into the computer and causing some physical damage to the platform itself, to the aircraft. This happened in the 90s, and actually, if I tell you now the Israeli story, 92, end of 92, beginning of 93, the internet spread in 1 year all over the world, and some people in Israel here, including myself, we were inspired by this science fiction, what was before this considered to be a science fiction prediction of an American writer called Alvin Toffler. He wrote about it in 1970, that is 23 years before the internet came, and suddenly all these science fiction seemed to be happening in a way. So I took those ideas with some philosophical ideas, and one of the main claims of Alvin Toffler was that in a book he wrote, which was called Future Shock, that the future will be entirely different from now. Now was 1970. It will be dominated by computers, and computers will change the nature of economy. Not only the nature of these machines or this capability, etc., but the nature of economy, because in the Industrial Revolution, after the Industrial Revolution, economy was based on producing and selling mass of products. Now it will be based on processing and selling ways to process, algorithms we call it, and things like this, of information. And information is not like a normal good. I can sell it to you and you and you, or to be more exact, I can sell the license to use certain capability to you and you and you, and still have the whole knowledge in my hands. And I was very much impressed by Paul Romer. He was then 30-something years old professor at the University of Chicago for economy, who wrote a lot about the change of the nature of economy. It will be based on information. If you ask yourself who are the richest people today, okay, as an indication, among the first 10 will be names like, I don't know, Bill Gates, Zuckerberg, and every kid knows those names. They are not industrialists in the previous sense, neither, of course, making the money from agriculture or land or something like this. They belong to this age. And when I met Professor Homer, by the way, some 4 years ago, he got the Nobel Prize for these ideas. When I met him here at Tel Aviv University, you can see the picture on the right side, I told him that Yaniv said, I'm considered here to be the founding father of cyber. I told him that he is the founding father of Israeli cyber. He was very much surprised, and he came and gave a wonderful lecture in our cyber week. Nevertheless, we are now in the what Toffler called the third wave of information. And then I told you we set up in defense, and I think we were one of the first, but I'm not sure who was the first in our defense forces in the IDF unit dealing with this new technology, cyber technology. And after a few years of working with it, we understood that the main issue is not doing something in information space. I mean, we started with this, as I mentioned, but doing some physical damage. You can, because in modern countries, every infrastructure, we started with critical infrastructure, but every infrastructure is really controlled by computers, not manually as it used to be. If you use this technology, you can cause a physical damage. So I wrote a letter to the Prime Minister, and I told him one day, everyone will understand it. The secret that we know now was 99, okay? One day everyone will understand it, and then the advantage that we have today, knowing it, will turn in one day into a huge disadvantage, because Israel, unlike all our neighbors here, is very much computerized. I mean, already in 99, there was not even one critical infrastructure in Israel which was not controlled by computers. And we have to do something. And this was the first time any government in the world, I think, decided, I mean, it was decided here in Israel to set up a new unit on a national level to protect critical infrastructure against cyber attacks. Then came 2010. 2010, someone attacked, as you all know, the Iranian uranium enrichment facility, and suddenly the whole world started to speak about cyber. Until that time, it was limited to intelligence services, defense organizations. It was considered to be sensitive, secret. Don't talk about it publicly, okay? But 2010, it was changed in a minute because it caught the attention of the media, and because it was the first demonstration globally for causing physical damage with this computer technology, okay? Centrifuges collapsed. It was not about doing something to the information. Centrifuges collapsed. And therefore I was called by the Prime Minister then, and he showed me the letter from 99, and he said, you said one day the world will be changed, and it will be, our advantage will transfer into disadvantage, vulnerability. I found myself leading a kind of task force that at the end of the day submitted to the government a plan how to make Israel one of the top 5 countries in the world in cyber technology. It was proved by the government. It was approved by the government in 2011, started being implemented. Now we are 10, 11 years afterwards. And the idea was to come out of the closet. This was the idea. I mean, until that day, everything we did was behind the walls of secrecy, sensitivity, etc., defense. The idea was that we will never be a real player in cyber world without making it legitimate for every activity, because meantime, Moore's law is working and computers become more capable, smaller in size, cheaper, and therefore spread into any field of our life, okay? You can find it in any field of our life, and what becomes vulnerable now is everything. I mean, transportation, I mean, even cars are controlled by computers today. Everything is controlled, and therefore you cannot keep it behind the walls of secrecy, of defense and intelligence. And the revolution we did here was in this sense. Take it and make it legitimate. That is, doing something to all those three circles here, government, including defense, academy, schools, education, industry. I don't have time, it's only 10 minutes talk, so I'll give you only the example of education, okay? 2010, when I submitted the plan, there was not even one university in the world. Now we are talking about ICRC, university, cyber research cooperation between countries. 2010, there was not even one university in the world in which you could go and get a degree in cybersecurity or study cybersecurity. You could go to computer science, study encryption. You could go to another engineering department and study how to make transistors or God knows what, networks. No one taught cybersecurity because it was sensitive. So we said, okay, but where do the students come from? Usually in a normal state, they come from high school, okay? But in high school, they never heard about cybersecurity. So one of the elements in our plan, and this is now for 10 years or so, we teach cybersecurity in high schools today. Today, I mean the last 10 years. The beginning, we had a huge problems of teachers, but 10 years later, it's working. High schools in Israel teach cybersecurity. We still have this old system that we call matriculation examination at the end of high school. You can choose for one as a subject for this matriculation examination, you can choose cybersecurity. And then after a few years of doing it, we came to conclusions that it's too late, high school. You have to start with elementary school. Now, we don't teach kids age 6 or 7 how to write codes and things like this. It's too early. But we teach them what should be done with this posting in Facebook, what shouldn't be posted in Facebook, how to tweet. It's a new world. The same way we teach them how to cross, this is taken from Israeli school, okay? Every morning if you live here, you know that every morning kids this age, elementary school, are regulating the traffic near their schools in order to teach them how to cross a road. And we live in a world that needs it. I mean, you cannot grow up without knowing it. The same way we need to teach them to live in this new world in which social networks, communications through computers, and therefore vulnerabilities like cyber ethical issues are part of our life. Stephanie mentioned some of the numbers. I gave you the numbers in cybersecurity. Overall, if you look at sales, what we call the global market, the numbers that we have, I mean, we are waiting now for the numbers for 2022, but 21 we have until 21 we have the numbers. If you look at the global market, Israeli shares a little bit less than 10% of the global share, and you know that we are not 10% of the globe. what is more impressive, if you ask me, is the investment in cybersecurity. Now, investment comes from two sources. One is government, very difficult to get the right data about it because governments keep it secret still. And the other one is business sector. So only as an indicator, we put here the numbers of investment by business sector alone, globally in cybersecurity, and then to what companies it goes to, the money goes to, okay? To Israeli companies, in 2018, we celebrated because we reached the goal of my plan from 2010. So we celebrated, it was 18%, and then it rose to 26, 31, 44%, which is even too much if you ask me, of the investment, business sector investment in cybersecurity in 2021 went to Israeli companies, which meant that all those startups, when we started in 2011, we didn't have a real industry in cyber. So we put the emphasis on startups. And most of the startups, as you know, fail. I mean, we are considered to be startup nation, this and names. 96% of the startups fail. Okay? Only 4% go and become grown companies, and later on maybe even big grown companies, what is called unicorn, $1 billion, worth of $1 billion at least. Some of them became unicorns. So in 2020, I think 2021 was a little bit more. 2020 already 1/3 of the cyber unicorns globally were Israeli companies. I cannot end it without mentioning AI. We introduced AI because of cybersecurity. We introduced AI in 2015 into our defense because we wanted to reduce, not to eliminate, but to reduce the tension between the effectiveness of protecting the networks on one hand and values like privacy on the other hand. I mean, if you want to catch the malware in the way, in the communication systems, the old way was to take every series of bits running from one point to another point and decode it, go to the content. If it has some malware signature, you do something with it. If not, you ignore it. But by doing it, you hurt the privacy of your own citizens. I'm not speaking now about the bad guys, okay? But your own citizens, which is democratic countries don't want to do. So after the Snowden effect, we decided one of the things that we started implement was to reducing the number of these sets of codes that need to be decoded by having a learning machine that will oversee the whole traffic of bits and filter out only those sets of bits which behave abnormally, okay? Because malware behaves in a different way than normal messages. And again, I have to mention that already it was Turing in 52 that after he wrote originally in the 30s, Can Machine Calculate, wrote another paper in the 50s called Can Machine Think, which is nowadays what is the base for AI. So we started implementing it, and then I found myself with another colleague leading, again, appointed by the government to give the government a plan of how to make Israel. This is the objective here. You see how to make Israel one of the top 5 countries in the world in AI. This plan started partially only because in the last 3 years or so we had political instability problems. This is the nicest way to say it. Changing governments, etc., but it already started. And I'll finish by mentioning you that we have two major conferences every year. One you all know is the Cyber Week, and the other one, which is going to happen mid of February, in 3 months or so, is about we call it the AI Week. Thank you very much.
Thank you, Itzik. You know, one of the problems to hear Professor Ben Israel is that when he described the history, it sounds so, you know, makes sense. You hear and you say, yes, this is the right thing to do. Being part of the 2010 process, I remember how complicated it was for Professor Ben Israel to lead the conclusions and to do the work after where all the recommendations were written. It took us, I think, almost a year to make all the process and the mechanism to make the government approving these recommendations. So when you hear it 10 years later, it sounds like we sat together, we write the recommendations, and the government approved, but it's always not so easy, and people were saying at that time, cybersecurity, maybe it is a fashion, it will pass in a few years from now, so why don't we have to invest so much? So just to give you a bit of a reference to show how is it. So I would like to invite our next speaker. This is a recorded presentation, and you already got a teaser to hear that this is one of the next things that we are going to hear. So we are going to hear Mark Cullinane, the director of the Office of Information and Communication Policy at the U.S. Department of State, and Dania will run it from here. Thank you.
Good morning, and hello to those joining virtually too. Thank you to the Taiwan Economic and Cultural Office and Tel Aviv University for co-hosting today's event and for inviting me to provide remarks for this session. Thank you to Taiwan for its leadership through the Global Cooperation and Training Framework to support this event. My name is Mark Cullinane, and I'm pleased to join you on behalf of the U.S. Department of State's Bureau of Cyberspace and Digital Policy, or CDP, where I am the Director of Bilateral Affairs for the International and Information Communications Policy Division. The CDP Bureau, launched in April of this year as part of Secretary of State Antony Blinken's vision to coordinate and elevate U.S. diplomacy on cyberspace and digital technologies. As Secretary Blinken said, our task is to put forth and carry out a compelling vision for how to use technology in a way that serves our people, protects our interests, and upholds our democratic values. Our Bureau is led by Ambassador-at-Large Nate Fick and advances policies to support an open, interoperable, reliable, and secure Internet as a foundation for a robust global digital economy, serving as the lead for the State Department on information and communications technology, cybersecurity, and digital freedom policy. Allow me to share some of our policy perspectives now. We view Internet access and digital connectivity as forming the foundation of the digital economy, with the power to help accelerate economic transformation and bridge digital divides. A safe and inclusive environment for all people, underpinned by respect for human rights and digital freedom, is paramount to allow all to enjoy the benefits of digital connectivity. The more people are connected, the more markets are opened, the more ideas are shared, the better we are able to coordinate on shared priorities. To help advance this vision, the United States has launched the Declaration for the Future of the Internet. One intention of the Internet was to create an open, accessible space where simple and transparent rules created space for innovation, connection, and progress. We want to sustain this successful model And the Declaration for the Future of the Internet does that by laying out our vision to protect human rights and fundamental freedoms of all people, advance the free flow of information and inclusive and affordable connectivity, promote trust in global digital ecosystem, and protect and strengthen the multi-stakeholder approach to governance that sustains the Internet for the benefit of all. We share this vision with more than 60 partners from around the globe, committed to upholding an Internet that is truly open and fosters competition, innovation, privacy, and respect for human rights. I am proud to note that both Israel and Taiwan have joined us in signing on to the Declaration for the Future of the Internet, and we thank you for your partnership. Artificial intelligence is also at the center of the global technological revolution, and advances in AI technologies present both great opportunities as well as challenges. The United States advocates for an international, multi-stakeholder AI policy ecosystem and works to build partnerships connected by shared values and a shared commitment to design, develop, and deploy technology for the benefit of society. One example of how we're promoting this vision is through the AI Connect program, which aims to empower low and middle-income countries to become part of more multi-stakeholder conversations on the responsible use of AI technologies. Also recently released its Blueprint for an AI Bill of Rights, which is a non-binding white paper that lays out 5 principles and practices to help guide the design, development, and deployment of AI systems in a way that is aligned with democratic values and the protection of civil rights, civil liberties, and privacy. In addition, Internet connectivity must be built on secure and trustworthy information and communications technology infrastructure. This means the United States advocates for security across the ICT ecosystem, including in 4G and 5G networks, undersea cables, and communications satellites. The public sector and critical network operators must prioritize working with trustworthy suppliers of technology, since security risks within any network cannot be easily mitigated. We share this view with many like-minded partners and allies, and coordinate our efforts to support this approach. The United States also advocates for supplier diversity in ICT infrastructure. Over time, the number of trustworthy suppliers of wireless networks globally declined to only a few companies, and this has been limiting choice and raising prices for secure equipment. As one solution to this challenge, we promote the industry-led and market-driven movement to open and interoperable approaches to network architecture, known as Open Radio Access Networks, or Open RAN. However, the public sector cannot act alone. The Internet can only continue to provide its benefits, and meaningful digital connectivity can only expand if they are supported by a multi-stakeholder system with representatives from the public sector, private sector, civil society, and academia all contributing. The private sector provides innovation and is home to technical expertise that the public sector sometimes lacks. The inclusion of civil society helps to ensure representation of diverse thoughts and views, accountability, and transparency. Academia provides critical research, input for policy development, and workforce development. Without having everyone at the table, we risk leaving out key contributions and perspectives. So how do we engage these stakeholders? First, we must continue to coordinate with each other at various global fora and in capacity-building engagements and discussions, like we are doing today. The private sector in particular houses expertise and resources that can be beneficial in capacity-building engagements. The public sector should also work with the private sector on workforce development activities. There is a shared interest on this front. Both public and private sector entities need well-trained talent to respond to the information technology challenges of the 21st century. Support for building workforce skills and cultivating talent is needed to make the digital future a reality for all. In summary, digital transformation can unlock unprecedented economic growth, inclusion, and digital freedom. Together, we can make progress toward our shared goal to enable the digital economy for more resilient, sustainable, and inclusive growth and development. We welcome your collaboration towards these goals. Thank you again for the opportunity to participate in today's important discussion, and I wish you a productive rest of the day.
Great. So thank you, Mark, for the talk and for the so important things and comprehensive perspective. And I know that for you, it's not obvious to hear someone as a recorded talk, so the next one will be in person. And this is my pleasure to invite Mr. Jun Shou Lin, Deputy Director General of the Administration for Digital Industries at the MODA. Please, it's our pleasure.
Good morning. My name is Jun Shou Lin. I'm the Deputy Director General of Administration for Digital Industry. It's a newly established agency in Taiwan under the Ministry of Digital Affairs. Yes, first of all, I would like to thank everyone here for participating in today's seminar. And I'm honored to have this opportunity to share Taiwan government's experiences in improving information security preparation for the global supply chain. Yes, my talk will be divided into three parts. First, I will outline the current status of Taiwan's ICT industry and its role in the global supply chain. And then I will use practical cases to illustrate the cybersecurity challenges faced by those ICT industry in Taiwan. Finally, I will share how we have overcome these challenges and raised Taiwan's ICT industry to a higher position in the global supply chain. Okay, I think this slide provides an overview of the global ranking of Taiwan's ICT industry. From this slide, we can see that Taiwan's IC companies rank world #1 in the following industry: wafer fab, gallium arsenide fab, ROM memory, mobile phone chip, IC packaging and testing. I think even in the field of laptop computers, industrial computers, netcom equipment, and cybersecurity equipment, Taiwan plays a critical role in the global supply chain. Okay, let's take a look at what challenges we face in terms of cybersecurity. As you can see on the slide, Taiwan's industries face three major cybersecurity challenges. First, critical information infrastructures face a remote operation risk. Here is an example. In May 2020, CBC, Taiwan's largest fuel supplier, was attacked by ransomware, and all payment systems at the gas station were down. And the second challenge is supply chain security. Here's another example. In 2021, Acer and Quanta were attacked by hackers. And this results in international OBMs to include supply chain security requirements in their RFP with OEMs and ODMs. You know, Taiwan is the major country for OEM and ODMs. And the third challenge is IoT device security. In 2021 and 2022, massive ransomware attacked the QNAP NAS devices and the ASUS Linksys Wi-Fi router. Okay, to overcome those challenges, the Taiwan government actively assists its industries in improving their preparation for cybersecurity issues. We believe that the supply chain security must include manufacturing security, software security, IC chip security, IoT device security, and the information security protection must be throughout the product's life cycle. And in order to implement Taiwan's supply chain security, we set up an information security service park in southern Taiwan to assist the companies in demonstrating and validating their solutions. And let's go through each of the security from the left to the right on the slide. First, the manufacturing security. As you know, Taiwan is in a leading position in the global semiconductor supply chain. So the Taiwan government assists the semiconductor manufacturing industry to strengthen their information security and formulate the fab equipment standard, which is called SEMI E187. Then let's focus on software security. We know modern software is a complex mix of proprietary, open source, third-party components, business logic, communication APIs, and protocols. And any type of security issue within this software supply chain can leave organization at the risk of security breaches. And considering that businesses are running bring your own device, and individuals have started using mobile apps more often, more frequently, it is clear that mobile apps are critical and must be protected from the root cause. Therefore, we have developed a certification mark system for mobile application security. Then let's look at the IC chip security. You know, the root of product safety in the supply chain is chip safety, because chip is in the very upstream of the supply chain. So the ADI, my organization, established the cooperative test lab on chip security, and develop Taiwan's chip security standard and testing tools to lower the barriers to entry for industrial players. Then let's shift our attention to IoT device security. Like product management, product information security is a cross-domain issue, and the gaps between many sectors must be addressed. And so we established a device certification and a labeling system for IoT devices. Finally, in the site application, as I said before, we have set up a demonstration site for supply chain security solutions. Now let's dig deeper in manufacturing security. In recent years, cyber attacks on companies have increased rapidly, and the semiconductor industry isn't spared. For example, in 2018, a major foundry in Taiwan, you know, what's the company? TSMC, was forced to pause production to investigate machines infected by ransomware. And to help prevent the future cyber attacks on factory equipment, the Taiwan government has been working with SEMI and Taiwanese companies to initiate the semiconductor equipment information security standards. And after a major industry-wide effort in 2022, that's this year, the SEMI E187 specification for cybersecurity of fab equipment was officially released. Okay, let's talk about the TSMC's effort in this event. As a leader in the global semiconductor supply chain, TSMC actively strives to improve information security in the industry. TSMC worked with SEMI and the Taiwan government in 2018 to establish the Taiwan Fab and Equipment Information Security Task Force, and took the lead in defining the specifications for Fab Equipment Information Security Standard. Now let's shift our attention to another very important cybersecurity issue, that is mobile application security. In the current era of the Internet of Everything, hackers' intrusion techniques are becoming more and more valued. Those common apps such as communication, games, and the social media may be lurking malicious attacks and result in personal data leakage. And to reduce the risk, in 2015, Taiwan government convened domestic experts in the field of information security to help guide application developers to introduce sort of security by design concept in the development of their software. And this mechanism is called the Mobile App Information Security Testing Promotion Scheme. If apps pass the certification, they can obtain the Mobile Application Security Mark, or MAS for short, which is the world's first application information security certification. And there are 3 levels of verification for different applications. Level 1 is an app without identification, and level 2 is an app with access to personal data, and level 3 is an app with transaction behavior. And let's shift to chip security. In 2018, Bloomberg Business reported on a motherboard company with a pencil-tip-sized Trojan hardware hidden amongst the hundreds of components. And in 2019, a cybersecurity company discovered that an IC design company's digital signal processors contain major security vulnerabilities. Chip security incidents frequently affect the global chip supply chain. So a chip security test lab has been established in Taiwan by combining the industry, academia, and research units. And the goal is to promote and upgrade Taiwan's chips to security chips, so as to build Taiwan a trustworthy partner to the world. And on November 30th, that's this month, the global platform will go to Taiwan and discuss with the authority for cooperation between both sides. Okay, and now is IoT device security. To improve the information security protection level of Taiwan's ICT products, the Taiwan government promoted the IoT devices information security standards and the certification systems in 2017, and guided many manufacturers to strengthen the security level of their IoT products. Currently, there are 6 IoT information security standards. They are image monitoring system, smart bus information communication system, smart street light system, air quality micro-sensing device standard, consumer network camera information security standard, access control system information security standard. Finally, in the site application, Taiwan has set up a demonstration site for supply chain security solutions, which is called ACW South. ACW stands for Art of Cyber War. And it is located in Shalun of southern Taiwan, and is a special room for information security and intelligent technology research and development. It has built to attract information security solution providers to settle in and build a physical beta display equipment. And currently, there are petrochemical infrastructure, smart electric grid infrastructure, solar energy infrastructure, semiconductor and smart manufacturing infrastructure, and other operation technology test platforms. And at HCW South, 12 types of simulated offense versus defense scenarios for key infrastructure were established by using the built-in machines. And it acts as a demonstration site to verify the protective capabilities of the solutions. I think this is the final slide, and it brings us to the end of this presentation. I'd like to review what we have covered. First, I start by describing that Taiwan has always been an important supply chain in the world. And then I move on to discuss supply chain security must include manufacturing security. So we launched the E187 semiconductor equipment information security standard. In terms of software security, we launched the Application Security Certification System, or MAS. In terms of product security, we launched the IC chip security standard and the IoT devices standard. We also show the demonstration side of ICW South. Now comes to the closing remark. I hope you find today's presentation interesting and valuable. I brought up some important points about Taiwan's information security preparation, and I am very confident that Taiwan will always be a trustworthy partner to the world. I'd like to thank you all for attending today. Thank you.
Thank you so much, Jun Chonlin. It's really inspiring to hear about so many things that the Ministry of Digital Affairs take care in different areas, and I think that it's clear how important this is for Taiwan, but we all understand how important this is for all of us as you being part of the supply chain and the producers of many of the components to other elements that we are familiar, other systems that we are familiar in the world. So thank you so much for your talk. And we are just after this so inspiring part with the keynotes, we are starting with our first panel discussion. And this is my honor to invite again to the stage Yaping Abili to be and to act as the moderator of this panel and panel discussion. So please, and it's our pleasure to have you here.
Participants, both here with us in person and online, good morning once again. My name is Abby Lee, the head of the Taipei Economic and Cultural Office here in Tel Aviv. I'm pleased to be the moderator of today's first workshop, Challenges of the Digital Era and Opportunities for Digital Transformation. Digital economy covers a wide gamut of discussions and technical specializations. Having someone from the government policy setting side to lead today's discussion once again reminds us we have to work together and think outside of the box. Digital economy is also a dominant theme in a global agenda setting, as it allows business to expand provision of goods, services across the borders, even to the extent market. However, operating in a digital economy can also be very challenging, as it goes beyond the familiar brick-and-mortar stores, organizational, industrial, and geographic boundaries, creating both new challenges and threats. During this section, we will have experts from Taiwan and Israel to share their visions and case studies to help us to understand how to address the challenges, but how to cope with the challenges, and even we can strategize an open, resilient, and sustainable digital future together. Please allow me to introduce our presenters for this section. First, we have Dr. Zhushen Hu Zhushen 博士, Senior Vice President of Industrial Technology Research Center in Taiwan, who will be presenting virtually. Next, Dr. Leo Tabansky, Head of Research Development of ICRC, Ambassador at Large and also the Chair of the Taiwan Digital Transformation Association, Ambassador Chen Zhenran 理事长, and Professor Gail Ostreicher Singer of the Coder School of Management of Tel Aviv University. After the presentations, we will move to panel discussion and open for questions and answers. Now, without further ado, I will give the floor to Dr. Hu to start the first presentation. Thank you.
My apology that I cannot attend this conference in person because other schedule. So I would like to present the Taiwan smart machinery development and opportunities in technology applications. Particularly, we are using AI and the cloud technology to enhance the local manufacturing companies' strengths. Okay, here is the content of my talk. So I will start to introduce some general strategy, and I will show you several examples of how this technology are helping our local industry to enhance their competitiveness. Okay, this chart shows the total market size or the revenue size of the Taiwan smart machinery industry, that including a lot of equipment and as well as components that are exporting or domestic use. So the total size is 1.3 trillion Taiwan dollars. It's about 42 billion euros. And it consists of 18,000 enterprises. So a lot of them are small and medium enterprise, and they hire around 340,000 people. And we expect the growth of the this industry to be around 1.5 trillion, 45 trillion Taiwan dollars in 2022. Okay, and to enhance the competitiveness using the modern ICT technology, there are three strategies that are promoted by the government as well as implemented by ICRC. The first one is how do we utilize the AI to tackle the industrial challenges. And one of the most important point is because a lot of technicians, they are getting ages. So how do we use the digital technology to retain their technique and the skills? The second one is cloud technology to enhance machine solutions. Nowadays, it's almost impossible to sell the equipment or machine alone without any cloud connection, because there are several functions that are needed for cloud connectivity. The third one is we would like to use the total solution to fit in the global supply chain. I'm sure that many companies or our clients in the world, they are also adopting the modern cyber technique or cloud technology. So our machine makers should be able to fit in that infrastructure. Okay, in the following talk, I know the cybersecurity is very important for this development, but I'm not going to talk about that because I'm not the expert in cybersecurity. But we do, when we implement these technologies, we do collaborating with our cybersecurity experts to implement some standards or to allow the some computer companies to help those manufacturers to establish their security level. So the first one is to use the AI to tackle the industrial challenge. As I said, a lot of experienced technicians, they are getting ages. So, and because of the low birth rate, it's very difficult to find young blood to enter the industry. So how do we use AI to retain the knowledge accumulated from those experienced technicians? That's a major challenge for our manufacturing or machine makers. So we use that to easing our bottlenecks. And like many AI practice, we first collecting data and analyzing the data, and we distill the data to some useful level. Then we use the modern AI techniques so that it, in some cases, is very successful to retain those experienced knowledge. One of example here shown here is Fitco Corporation. Okay, Fitco Corporation is the they are making the a product that has the fluorescence, the magnetic powders on the surface. Okay, but previously they need a human inspection to see the residuals of those powders, magnetic powders, and then those magnetic powders can be detected by fluorescent light. So, but however, the environment is not so clean, and so the workers were facing some hazard situation. So we use the CCD camera and to detect the defects or residuals. But as you can see from the picture, okay, unless you are experienced worker, otherwise you cannot see what is the defect, what is the correct result. So the AI in this case is very useful. So we use the data annotated by the experts and then use the AI to train the computer to do so. Another one is TIRC company. The TIRC company is a robotic makers in Taiwan. And recently they have a project that collaborating with our utility company, Taipower. The need is that there are a lot of transformer stations outdoor, and those stations require regular maintenance. Okay, so a lot of people will go around and regularly to do the inspection. Okay, you know that the utility is very important for industry, so there's no should not be interrupted. So the inspection is very important. So the company provide a robot, as you see here, mobile robot, with different type of sensors, including camera, infrared, anything. So they can capture the image of the whole transformer station and send the image to the cloud. So the cloud can use the train the AI by AI technique to see the anomalies or if there are some a situation that is going to happen. So this will reduce a lot of labor costs and also enhance the efficiency to maintain the transforming station. Okay, the second strategy is using the machine cloud to enhance the machine, use the cloud technology to enhance the machine solutions. And on the left side of the transparency or the slides, we select 5 very important industry. One is metal forming, metal machining, electronics, etc. We talk to the industrial leaders to ask their members to joining the machine cloud established by ITRI. And so far, we have a member of 1,350 companies, and we created about 200 apps. Those apps are stored in the cloud, so the machine makers, they can download those apps. Of course, this behavior has to be secure. So in the machine clouds, we also implement some cybersecurity solutions to ensure that the data won't be stored or stealed, or other people are easily to get into their machine. One example is a company called Building Precision Machine Company. And this company is making a PCB screen printing machine. And they have business in Southeast Asia. So their machines are installed in other countries, but the operation or the monitoring station is in Taiwan. And so they use the machine cloud, the cloud established by us, so that their machine can have up-to-date functions that download from our cloud. Okay. The second example is the Jinfeng Machine Industrial Company, and the company is a leading stamping presses manufacturer. But however, to ensure 24/7 operation, they need equipment detection capability and some visualization to maintain the health of the machine. So they also adopt the cloud technology, so that we develop some apps and to connect it to the cloud, so that they can remote monitor their machines that was sold to other countries. Okay, and this enhances some performance, real performance of their customer. Okay, and the third one is FES Group. They are specialized in advanced injection molding machine and the molds. Okay, just like the previous story, they also, because their machines are sold, I think a lot of them are sold to Europe. So we have to establish further communication standard, at least proposed by the European country. And they also install productivity maintenance module, management module, and a quality inspection module to help their customer enhance their productivity. And the feedback from the FES director is that the product and the service differentiation is the best way to create value. So I think they appreciate this because they are all traditional companies, very traditional. So they try to embrace the ICT technology, but it really needs help from the community to implement those functions to their machine. Okay, this is a very simple view of our global supply chain. A lot of our small and medium enterprise, they are utilizing the ICT technology to establish their connection to the customer worldwide. And I think this is what I said. We need. I think this is very important for the traditional machine makers to enter the world. Okay, and an example is Techman. Techman Robotics is a company that making cobot. Okay, so they have their own cobot design and the manufacturing with built-in cameras, and they also include a lot of software, so that when the customer use the robot, they can easily implement various functions from their software. Especially, they include a predictive maintenance needs, not to optimize the downtime. Okay, so I think a lot of European companies are collaborating with Techman Robot, so that because they implement a lot of advanced software features to enhance their capability. And for semiconductor, there's a company called Hallett Tech Corporation. Their specialty is the exhaust monitoring system. So they made a lot of valve. The exhaust system can be installed in vacuum pump or scrubber. Okay, for example, for chemical vapor deposition process, CMP, there are a lot of pumps, valve, and the scrubber. So they install sensors to those elements, and they get a lot of data and analyze the data to reduce the equipment inspection manpower, to reduce the maintenance time, and increase the utilization. Okay, so this is very successful for utilizing the AI techniques in semiconductor. Okay, and another example is FKI is a smart blowing mold machine. They sell the machine for a lot of clients to blow, for example, like plastic bottle or other products. Okay, and they also establish the network communication with the machine. Okay, and they made a smart material fee system, and all the electrical servo systems are monitored and optimized. So one of the benefits is to reduce the electricity needs by 70%, and the heating efficiency increased by 50%, and reduce the CO2 emissions. Okay, so this is a very good example of using the modern technique, also to enhance the greenness, or we call the reduce the carbon emission of the manufacturing. Okay, so this concludes my talk. I think we are still working on many other things that will enhance our manufacturing capability, utilizing the AI and the cloud technology as I presented before. So this is, we are still doing that. And we hope that through this technique, we can collaborate with more and more companies worldwide. And of course, the cybersecurity will be a very important issue when we implement the network connectivity and also the remote monitoring technique and the AI technique. Okay, thank you very much.
Next, we are going to invite Dr. Leo Tabansky, Head of Research Development of the ICRC, to give his presentation. Please, thank you.
Thank you, and thank you for the opportunity. Now, I would like to talk more about what we are doing here in terms of research. One of the reasons that, perhaps the main reason that I enjoy working in the university, in Tel Aviv University, is the opportunity to tackle really big problems. Yeah. So how do we build resilience for the digital economy is for me a more interesting thing than the traditional approach to cybersecurity is a technical or defense-related topic, which is of course important, but not enough. Now, as we talk about digital economy, it's soon will become redundant, the word digital. I mean, everything has digital components, and therefore cybersecurity is a means to increase the resilience of the complex systems that our societies and economies operate with. Now, this is an important part. When we consider the traditional practices of the industry in cybersecurity, they are usually focused on one well-defined boundaries of a system, a technical system or single organization. And we know from both the practices of critical infrastructure protection, which in Israel has already accumulated some 20 years of experience, and more importantly from science of complexity and networks, that resilience is not a linear function of how strong your security, technical security is. It's an emergent property of interactions between social and technical parts in complex systems, which are our societies too. So we devised in the last 3 years, the team that I'm leading here in the Blavatnik Interdisciplinary Cyber Research Center, we devised the cyber capability maturity model that analyzes and then recommends activities to improve resilience of the sector of economy. Sector of economy would be a good example for bridging the gap between individual firm approaches, which are the most common practice in cybersecurity, and some national models that we already have in the world. How do you bridge this gap from individual well-defined system with specifications and so on to a sector? For that purpose, we have designed 4 dimensions of operations. And when we analyze the sector, we analyze the large corporations providing the service itself, then the regulatory agencies that have at least potentially the responsibility and accountability for ensuring certain service levels that it will deliver. Supply chain is the third dimension. It's integral to the model, unlike the current fashion in the recent years in cybersecurity industry to suddenly put attention and emphasis on supply chain. And finally, the national capabilities that usually are positioned in law enforcement or cybersecurity agencies. This approach systematically allows to get a holistic understanding of how a certain important service is being generated and delivered, and then work to increase its resilience. The things that we assess are similar to what cybersecurity models assessed and well modeled to cross-reference to NIST CSF. Again, the important part is the architecture that allows us to have a much higher resolution of assessment and then identify better the gaps and recommend the actions to perform in order to design sustainable resilience in the sector of economy. Now, in one sense, we are obviously delivering a much better assessment of the reality, again, because we do not focus only on the specific plant. Okay, if we will take the example of the semiconductor manufacturing in Taiwan, then, of course, much of the discussions that we would focus on would be on the particular companies that are dealing with it. But in that case, we would unfortunately leave out the influences of the supply chain, the potential supervisors and government agencies, as well as security and defense agencies. In our model, we would have to include all of them in order to better understand the environment, and then perhaps, or ideally, this is the goal of the model, to be able to deliver a much more cost-effective and actionable recommendations where to emphasize the security efforts. Now, security standards are fine. Unfortunately, very few sectors and organizations are able to cope with them and implement all that standards recommend. Therefore, these recommendations that we are talking about and the progression paths are different from a standard. They are accepting the inevitable fact that much of the things that they would like to do would be impossible to do for economic, social, organizational, and other reasons. Therefore, the need to find the few critical points in the sector is the most important part. So this model has already been transitioning from basic university research to applied work, where we have been analyzing interesting sectors in the financial sector and the energy sector worldwide. We do have already important partnership with the World Bank, where we work with them to help generate a better understanding of the risks and the mitigations to the investments that they perform together with different stakeholders in advancing sustainable development goals. A big difference here, of course, that in this conference we have participants from 3 high-income countries, United States, Taiwan, and Israel. However, most of the world's population is not living in high-income countries, and this is a huge mission for the world and for the academics and for the industries to help bring digital resilience first in order to improve the lives of millions and millions of people worldwide, but also to generate the conditions that will enhance the stability of the international relations and decrease the chances of all sorts of disturbances that can happen when economies fail and states fail and so on. So this is the model that we have developed. As I said, we are already partnering with the World Bank in order to pilot and demonstrate the value of the model. But we definitely are looking for more partnership and cooperation. On the one hand, we as a university unit already can provide advisory services. This means implement this with our team of practitioners that we source from the Israeli industry. But more importantly, perhaps we accept that, and we always, this is the default, that we don't know much. Yeah? There is much to be gained from partnership across disciplines, across cultures, with people with different expertise. So we are very much looking forward to establish beneficial and mutually beneficial partnerships and cooperations with academic and government institutions worldwide, so that we will be able to contribute our part to the promotion of sustainable development goals worldwide. So this is the connection in our view. Again, cybersecurity is not just a vertical of some industry or a technical discipline. This is an essential enabler of digital economy as well as sustainable development worldwide, and we are here to help everyone to achieve it. Thank you.
Okay, thank you, Leo, for touching upon how we can build resilient cybersecurity together. Okay, next speaker, we will have Ambassador Large for Digital Affairs appointed by President Tsai. Chair Chen is a very famous figure in Taiwan. He is the founder of our local search engine, and that also provide first platform for a lot of Taiwanese to get immersed into the cyber world. He also is a strong advocate for the public and civilian partnership in digital transformation. So really honored to have Chairman Chen to give the presentation today. Thank you.
So, which one is? Sorry. So I'll use this to control. Okay, I see. Okay, it's really my great pleasure and privilege to be here to give you an overview of Taiwan government's effort in building Taiwan as a digital nation by leveraging the digital and green technology. To begin with, sorry. Whoops. Why it's not working? Okay. To begin with, I will give you a short introduction of our digital nation program called DigiPlus and the achievements so far. Next, I will talk about the most important features of the Phase 2 program and key areas Taiwan and Israel may work together for a win-win partnership in the coming future. Okay. Why Taiwan initiate DigiPlus program? Because with the foresight of the disruptive and transformative nature of digital technology, in 2017, our President Tsai Ing-wen led the government to launch the Digital Nation and Innovative Economic Development Program. It's an 8 years strategic development program known as DigiPlus to lay the foundation for an inclusive digital economy and society. As you can see in this graphic, DigiPlus program involves almost all military and private sector to work together to upgrade the nation. The goal of DigiPlus is to develop Taiwan into a digital nation featuring a civically active, connected society and innovation technology. The program starts with the strategy, as you can see at the bottom side, the strategy of building Taiwan's digital infrastructure, which enable innovation in your left-hand side, and e-governance, which in turn empowering balanced urban-rural development and improving citizens' life, and ultimately driving industry transformation and the growth of digital economy. This kind of focused effort boosts Taiwan's competitiveness. We have one of the highest penetration rate in household broadband connection and the use of broadband mobile devices, and etc. And the most important, by that we have built a pretty sound business environment that you can have best profit opportunity doing business there, according to the research of Barry, which stands for Business Environment Risk Index. And the phase one program of DigiPlus has laid a solid foundation for digital economy in Taiwan. Specifically, it has helped to improve Taiwan's digital capability, develop the country's digital economy, and build Taiwan's economic resilience. The uplift of Taiwan's digital capability is reflected in the rank improvement in IMD, which is Institute of International Management and Development in Switzerland. As World Digital Competitiveness Ranking, as you can see in this graph, Taiwan moved from 16 in 2018 to 8 in 2022, and there are many sub-categories. Taiwan has ranked number one, just like Stephanie said, Taiwan has the best research personnel per capita in the world. And the next slide is even more exciting, that it shows how Taiwan's value-added manufacturing rate improved visually as DigiPlus ramp up. In terms of MTA, Taiwan's manufacturing value-added rate has increased significantly since 2019, attributed to the increase in the share of IT and electronic sector in total value added, and the higher output of the manufacturing sector. Whoops. Oh, sorry. Okay, the digital capability of Taiwan's ICT and manufacturing industry helped to build Taiwan's economic resilience. As you can see in this graphic, the red line in the slide shows how Taiwan as an economy outperformed the average of the worldwide and our Eastern Asia counterparts during the worst of the pandemic. It shows economic resilience. I would argue it was supported by our national program, DigiPlus. Okay, now DigiPlus has entered the second phase with upgrade goal of building Taiwan into an innovative, inclusive, and sustainable smart nation. To achieve this goal, on August 27 this year, Taiwan government has established the new Ministry of Digital Affairs called MODA, okay, and led by the Ministry of Audrey Tang. And more importantly, the fundamental focus of the current phase is going from just digital transformation to digital and green dual transformation. That means Taiwan will now leverage both green and digital technology to facilitate industry and social transformation. Digital transformation makes us more competitive, as we just seen in the before slide. But if you don't have green transformation simultaneously, you will not be sustainable, no matter how digital you are. So the Nation Development Council has developed a clear pathway and core strategy to upgrade Taiwan's energy industries, citizen lifestyle, and the entire society. And in addition, the second phase of Digital Plus, Taiwan government has launched a service-oriented smart government program, which aims to improve smart governance capability through the use of open data and encourage data-driven and evidence-based policy making for both public and private sector. And in this graphic, we can see the relevance of phase 1 and phase 2 of the DigiPlus program. In the first phase, we have built the common digital infrastructure and laid the foundation for innovative industry development, as you see at the lower part of the graphic. Now and more relevantly, the government has identified 6 core strategic industry, and will develop these industries with some commitment, heavy investment, and supportive incentive. And as you can see, there are these 6 sectors. Okay. And I think it's where we think opportunity for collaboration of Israel and Taiwan can be, since both countries' competence is complementary, and we should be able to leverage both countries' innovation ecosystem and grasp potential business opportunity brought by dual transformation. And this graphic just to show a number of areas that in which Taiwan and Israel can explore collaboration opportunity. Oops. I think I don't go through that because in the interest of time. And then there are many more topical themes Israel and Taiwan can work together, as our government will continue to attracting investment in this area to foster digital innovation and facilitate green transformation and encouraging international cooperation. So today I spent only a couple of minutes to brief how Taiwan has done to anticipate digital economy by implementing a national program called DigiPlus. And we to see is make Taiwan more competitive and resilient. And we are moving forward by focusing on dual transformation. And I believe dual transformation is important not only for Taiwan, but for everyone. So I hope through today's exchange, we can facilitate international cooperation to accelerate and create a win-win situation. So let's conclude my presentation. Thank you much for your attention.
Thank you, Chairman Chen. The above 3 presenters all highlight the open, resilient, and sustainable digital age. And the next speaker will share her presentation from different perspectives, more from the social and economic perspective. Now I will have the floor to Professor Gale. Thank you.
Hello. Thank you, everybody, for coming. My name is Gal Ostreicher, and I'm actually a professor from the Kohler School of Management. I have degrees in electrical engineering, but also in law. So I want to speak today. Better? Okay. And I want to speak today from the interdisciplinary perspective and specifically focus on the role of social sciences in this future we are talking about today. I will try to start with 3 facts, which I think we can all agree on. Fact number 1 is that humans are the ones to design the technology. Fact number 2, humans have biases and prejudice. And sometimes, unconsciously, those biases leak into the technology the humans are designing. And we call this algorithmic biases, right? So one example would be facial recognition software doing a much better job identifying white faces versus colored faces. And this is clearly an error on the end of the human designers of the technology. So this is only one example, but I think we can all agree that the AI-driven future we're all hoping for will not be gender blind, race blind, unbiased as we initially thought. Not if we don't have a conscious intervention to make it so. Which leads me to my third point. My third fact is that we are increasingly delegating important decisions to AI and automated systems. And this is not the crowd I need to explain this statement to, but I do want to refer you to the phenomena of algorithmic management, which in the business school we have been giving more and more attention to. Algorithmic management talks about a situation where we delegate managerial functions to AI and automated systems. So a natural example will be an Uber driver. Okay? The technology dictates where the driver goes. It dictates which drivers get more work, how much they get paid. Is this surcharge or regular price? And how much penalty they have to incur if they don't meet you at the meeting point or if they take a different route. I'm sorry. So, and those Uber drivers, they don't have a human manager really that they can turn to with complaints or questions when the algorithm seems to be unfair or unclear. Right? And so we call this algorithmic management, and we started having research on the important consequences to the workers in different industries under the regime of algorithmic management. So if we put those 3 facts together, humans design the technology has biases, and then the technology has tremendous power over us as humans, it's clear that we actually have a social responsibility to actively think about ways in which we can introduce change and improvement into the technology. And we do know that we have to be conscious about algorithmic bias, but I want to say that we can do more. We actually must do more. We must actively think about ways in which a technology, any technology, can be an opportunity for change and improvement and maybe even mitigate some of those biases that we're unable to root out. And I'll share an example with you. I'll share an example with you. One known fact is that for a variety of reasons, females tend to underestimate their contribution and tend to ask for less pay for the same job compared to the male colleagues. And this was also evident in hiring.com. Hiring.com is a platform for job seeking. And they've seen that consistently in Hire.com, the job seeker has to enter the pay that they're expecting for the job, and consistently the female job seekers were asking for less pay for the same job. So they've done a small change. Okay? They started telling the job seekers what is the AI predicted average or median pay for that job. And this small change had a tremendous success. It almost completely eliminated the gender ask pay gap that they've observed before. And by the way, didn't lead to less jobs getting to female workers. Okay, so this simple example is an excellent demonstration of the kind of change that we can introduce using innovation that can actually mitigate some of the biases that we are all still carrying. Now, I want to talk about one more point, which is whose responsibility is this? Who should assume the role of making sure that our platforms, our AI tools, our technology in general introduces positive social change. And ideally, the answer would be everybody, right? The engineers, the policymakers, the managers, but I think the social sciences actually have a very unique role in this context. Because if we think about it, social sciences are the disciplines that traditionally have documented biases and studies change in society. And so social sciences can actually be the watchdog of our technology future and can lead for this call for proactive thinking about change and innovation and mitigation of biases. Okay. Now, I want to kind of conclude this. I know I'm the last one, so I'll be quick, but I do want to conclude this with a story that I think reflects a lot of the issues that I'm raising here. Back in 2018, Airbnb introduced a new tool for its property owners. It's called algorithmic pricing. And this tool is an AI-based tool that tells each property owner what is the revenue maximizing price that they should ask for the property. And this tool was very successful. It actually, on average, recommended a decrease of about 5% in the ask price for the property, but led to about 8% increase in revenues. Okay? So 5% decrease in price and 8% increase in revenue. Now, I should stop here maybe and mention that it has been documented that there is a race revenue difference in Airbnb. And all else being equal, a white property owner will make $12 more per night for the same property compared to a black property owner. Now, knowing that, the question is, what happens when we have AI algorithms dictating the price? And the answer is, as I told you, price did well for everybody. All property owners were actually doing better, and this algorithm actually shrank a little bit the price difference between white owners and black owners. So far, so good. But researchers have argued, this is an interesting point, that this race-blind algorithm was suboptimal. That if the algorithm took into account the race of the property owner, they could actually lead to higher revenues for that property owner. So now the question is, what should the platform do? Should they help each owner maximize their revenue, given the current world we are living in, include the race as well? Or, and of course, at the same time, increase the revenue gap between, the race revenue gap between blacks and whites? Or alternatively, should Airbnb actively continue being race blind in order to mitigate this race revenue gap at the cost of the revenue to some of their black property owners? And I'm not going to answer this question. I want to leave you with this question, but I want to say that questions like this are going to come up more and more in the current future. And as we transition into automated systems that actually have even more governance and ruling over our lives and our work life, we're going to have to address more and more of those questions. And I want to encourage this interdisciplinary and very proactive discussion of the consequences of technology and the opportunities of technology to mitigate biases. And until humanity actually improves as a society and roots out biases and prejudice, could we find a way to use technology to at least mitigate some of those phenomena? And that's it for me. So thank you very much.
Thank you, Gail. And now I would like to invite Chairman Chen and Leo come to the stage again to join our panel discussion. Thank you for the stimulating presentation. Over a lot of thought for further discussion and further cooperation. I would like to have some follow-up questions for our presenters and panelists today. If I may, I would like to ask when an organization develop their blueprint or strategies for digital transformation, what advice will you give to those organizations, or what kind of advice will you give to the global government to focus on further enable organizations? Also, I come up with questions, maybe Gail can answer this part. How was the rising inflation and potential recession might impact the transition digitally, and how it will impact the digital equality? And then I know that Leo has a very long-term research on the cybersecurity. Maybe we can talk about the roles how small countries can play in global cyber resilience, or does the size of the country really matters in cyber resilience? So in order to enhance the equality, Gail, you are the last one to present. I will have you the first one to answer the question. Thank you.
It's working? Okay. Okay, a lot of questions and very little time. But it is working? Yeah, okay, good. I'll talk about the global economy currently, and I would say that if COVID taught us anything, it was that those that were fast to respond and digital transform were the ones that actually succeeded in those troubling times that we had also in the technical perspective. And in that sense, companies that would know, or countries that would know how to respond to the global economy fast and using technology are probably going to be the ones to prevail. The problem is, of course, that in times like that, the heavy investments are more difficult to do, and sometimes maybe it gives an opportunity to the smaller companies or the more agile companies and countries that respond to the situation properly.
So about the role of smaller economies. First, there is expectations that smaller economies or smaller organizations can be more agile. There is some correlation about that, but it's not the most important part. I believe the more important part stems from the unique properties of data as a resource and a generation of value. Data is intangible good, and if we have some information and knowledge, it doesn't mean that our competitors have less or so on. It doesn't take from them. So with that, the issues of traditional resources, land and capital and labor, become less influential. Therefore, theoretically, there's a huge potential for small economies to play, smaller countries to play outsized role in a digital economy. In cybersecurity, it's one thing. In cybersecurity as an economic industry and driver of revenues and so on. So there's a great potential with that. And nevertheless, of course, we cannot possibly compete with the superpowers, and we shouldn't, because our goals are different and needs are different.
I have read a couple of research reports about digital transformation, including one from WF and McKinsey, and they ask they conduct survey to ask the leaders of worldwide enterprise, say, hey, you have spent a lot of money during the pandemic. How do you think you achieve your goal? Amazingly, only in both research, only around 15% of the leader of the enterprise say, yes, the investment is effective. So that means the majority of the digital transformation didn't work. Okay, then why? I read a research released by IMD. They found the most common reason for the failure of, or I should say unsuccessful plan of digital transformation is because the organization lack of a coherent strategy. Okay, so I think if you want to be successful in digital transformation, the first thing is stop and evaluate the situation of your organization and build the coherent strategy for digital transformation, and must have good communication inside the organization, okay? And when in practice, there are two advice. The first, find a quick win case. Don't do the most difficult part of digital transformation that only can make your organization and your employee frustrated. And second, collaboration. Okay, since the complexity and the wide range of the digital transformation touches, I think no single organization can do it by itself. So work together, especially work with cross-domain experts is very important for a successful digital transformation plan.
Thank you. I think we are running out of time. Don't have time for question and answers, and we can exchange more views during the networking lunch or the coffee break later. But final questions, maybe what we have a presenter to comment on this one is, as you've seen the digital economy also, or digital age take share over the last 2 or 3 decades, what excites you the most about the road ahead?
Actually, the unknown, I think, would be the best answer, right? Because this future is going to get even more interesting and more AI-driven. And the question is, how are we actually going to use it? And the potential good that we can do, talking about green technologies, etc., I think that would be the most exciting to me, the do-good technologies that we could develop.
Yeah, absolutely, I would join. I mean, did we, in the, let's say, in the high-income countries, did we get this thing right? Did we get cybersecurity and digital economy to work? Absolutely not sure, okay, to put it mildly. So there's huge potential for breakthroughs and unlocking a great value and helping the entire world to people, yeah, to get better lives and safety and so on.
I think the best tool is that we don't see any tool will work in the future, okay? Because the profound change bring by digital technology let us have the liberty and obligation to think about what is the tool to help us to govern the coming digital era. So I think that is probably the worst part and the best part, but it depends on how we handle it. Okay, thank you.
Okay, the things that we are not sure definitely give us more room to cooperate and to discuss. And thank you for your time for session 1. We'll move to the coffee break, right, Daniel?
Yes.
Okay.
Hi. We'll have a very short coffee break now.
From the Department of Economic, Tel Aviv University, talking about empirically evaluating the effect of cybersecurity precaution on incidents in Israeli enterprise. And later we're going to introduce the other speakers and myself. Thank you, Yaniv.
Okay. All right, good. So I'm happy to be here. I'm sorry that I have to sort of like talk and run, but I need the mic? Why? Okay. Then I think I'm going to pop everyone's eardrums. Okay, so the title is bad, but the paper I think you'll like. Okay, so that's, I mean, if anyone has a better title, let me know. I just want to say this is joint with my longtime colleagues, Mike Reardon from the University, from Columbia, and Tyler Moore, who's a computer scientist from the University of Tulsa, and we've been working together, and on this particular project, we have a, oh, sorry. Sorry about that. Okay. Okay, that's better. We have a joint NSF-BSF on that, on this grant. For this project, and we've also been working, and Noah Barnir is a PhD student of mine, and she's excellent too. And we've been working with the Israeli National Cyber Directorate for the last 2 to 2.5 years, and in particular Itai Ben-Arzi, who's unfortunately no longer there. But what was done in Israel, something very, very special, and they did an excellent survey on cybersecurity. In other words, they asked questions about what precautions you used, and whether you suffered incidents that you had to address. Now, other data in the past has had these properties, but there's a huge problem, which I'll tell you about. I think I'll tell you about it right now. Okay, if you look at let's go to this graph, if I have it. This graph. If you look at the number of security measures, and we have 20, and I'll talk about what they are. If you look at the relationship between the number of security measures and the probability that the firm suffered a cyber attack that it had to address, you see a positive correlation. Of course, that's insane. Okay, it doesn't mean that the more protections you have, the higher probability you're going to suffer an attack. What does it mean?
It's a reaction.
It's a reaction to what?
Fear.
It's a reaction to what?
Fear.
No, not to fear.
Or you have selection bias.
No selection bias. This, by the way, is a great survey. 2,500 firms were.
The size of the companies.
No, we control for that. Moshe, that's an excellent point. We control for the attractiveness of the target. So we take that into account, the attractiveness of the target, which is size, the revenues, whether they're in a particular industry, whether they have websites and things like that. We control for all of that, but still, if you don't control for one more thing, you get this. What's the problem? Okay, it's good that nobody knows, but you know.
More attack.
What?
Because you implement more security measures, so you detect more attacks.
No, it's not that. It's not that, although that could be a small part of it. What it is we don't know the timing of when these firms put on the security measures. So many of them have done what is called reactive security. Okay, in other words, after getting attacked, you see, I'm starting to talk Hebrew. Even in the U.S., I was lecturing in English, and the words came out in Hebrew. Okay, but what happens is they suffer an attack, and then they put on all these security measures. And of course, none of the surveys ever ask, that kind of question. So we have to be able to sort that out. Okay, and what was really done? Okay, I think I'm going to have time to talk, so I'm not going to go through all the results right now. We're trying to see if we can sort this out and see whether security precautions and firm characteristics, which make the targets more attractive, it's a function of incidents, we control for firm characteristics. Our goal is to see whether security precautions help. So we have a wonderful survey, 2,500 firms representative of the Israeli economy, and because it was a survey joint with the Central Bureau of Statistics, it was required. Firms had to fill it out, and it was specially asked that the chief technical officer of the firm fill it out. And it covers all the Israeli economy, so there's not a selection bias here. And there normally is a selection bias in surveys, but with an 81% response rate, you're just, jumping through the sky, and so to speak. Okay, the firms were asked 20 questions, and they had to say yes or no, whether they used these measures or not, but they weren't asked about when what the timing was. Now, I'm not going to go through all 20. I'll just tell you that some of them are pretty simple, and they can be implemented very quickly, even by someone like me, who's not very good at at working with this kind of stuff. Okay, and some of them are more complicated. Anyway, firms were asked about that. Okay, and we actually wanted also to look at 6 basic measures. And the reason I wanted to look at 6 basic measures is I'm going to try to convince you, I think I'll be able to convince you, that I can sort out the timing of when the firms made these, put on these security measures. So the basic ones are things all of you guys do, strong passwords, 2-factor authentication. I don't like reading slides. You guys can read through. Okay, 40% of the firms in the database used all 6 of these basic measures. So keep that in mind. Okay, now, here's the brilliant question that the survey asked, and it's something that enabled us to do this. And no survey anywhere in the world has ever asked these kind of questions. So this is the first time when you're going to see results. Okay, they asked the question, was your enterprise aware of cyber directives that they issued in 2017? Why is the timing important? Because the survey was sent out in 2020, okay? And firms were asked whether they suffered attack in the previous year. So the earliest attack that would be counted is actually June 2019, but we even say, okay, we'll go back to the beginning of 2019. So, but these directives were published in 2017. It's like playing soccer with these things. Okay, I used to play. Okay, now, so this question was asked, and then if you said yes, that you were aware, you were asked whether you implemented them or not. And as luck would have it, the data broke in a fantastic way. First of all, we can only use firms who answer yes to the first question. So that eliminates about half of the firms. That's life. By the way, I'm working with the Central Bureau of Statistics to do a follow-up survey, but it'll probably take another 2 years. And then we maybe can address the timing directly. Okay, and then the second question, again, it was really nice because it kind of split equally. People who said yes to the first question were asked, then did you implement them? So again, yes or no, and it kind of split equally. So that's great, and this is what we're going to do with our timing issue. Because what we're kind of saying here is firms that read the directives, said they read the directives, and they implemented the directives, they're firms that care about security, and they're more vigorous than other firms. And I'll show you how it kicks out empirically, but I think that's a reasonable assumption. I can't say that all the firms that answered yes to question 2 put all their security precautions on early, but probably in the case of the basic ones they did, and you'll see something pretty cool in the data pretty soon. Okay, by the way, ask me questions if you want, if I'm going too fast or too slow. Okay, so this econometricians call an instrumental variable, okay? And I'll tell you why, but it takes the value 1 if the firms implemented the directives, not talking about the 20 security measures, and 0 if they didn't, okay? So it's gonna address the timing for us. And something you need for an instrument, you need it to be correlated with what it's instrumenting for, which is the number of security measures, and we'll show that it is. And you also need to have it such that the hackers don't see that the firms answered it. So of course they don't, because this is a private survey. Think about crime. If you put up a sign that says your house is protected, then somebody will rob your neighbors. Okay, but here we don't have that problem. Okay, this is the slide where everyone has to pay attention. So put away your phones, everyone. Okay, because this is a good slide. Okay, this is the key slide. This is really cool, and my PhD student Noah, I think, was the one who first showed it. Usually, when you do this kind of stuff in economics, when you use sophisticated econometrics, it's not too sophisticated, but when you do what are called instrumental variable regressions, which probably nobody in the room knows of, you don't know how it works. Here, I'm going to tell you why it works. Okay, so I'm going to move these chairs out of the way because I have to go over here. Okay, so we're looking now at firms. These firms all used the 6 basic controls, okay? So these are firms that all put on 6 basic controls, but we don't know the timing. Now, for those that did full implementation, they're the blue guys, okay? So you can see that the probability of suffering an incident that had to be addressed for the blue group is less than 50%. Can everyone see that? Because it's this divided by this plus this. Okay, these are the blues the blues all did implementation. Everyone over here used the basic controls, okay? If you don't see this, ask, because this is the key thing of the paper, and this is how you have to do this kind of work in order to make it come out right. Okay, so these are the blues. They implemented their probability of attack. By the way, it wasn't so low because, firms that are attractive targets are attractive targets, and they're going to suffer incidents, c'est la vie. Look at the difference, though. Again, these are all firms that put on these 6 basic controls. Look at the ones who didn't implement. The probability of an incident is about twice as much as the probability of no incident. So there's a huge difference in the probabilities. And that's what makes the instrument work in practice. Now, that's true. I can't say I know that all of them who said that they implemented did it early. But it's enough. It's enough, and you'll see from the results it's enough that I have this. Does everyone see this? Because that's the key thing of this, that's the key thing here. Okay, and again, this is exactly what I said. One other thing that's kind of nice is over here, there's kind of no difference. You know, there's no difference over here if they didn't use the basic controls. And that again, technically helps the instrument. In other words, here the probability of, you know, an incident is kind of small in general because these are firms that, you know, are not big targets. Okay, so they're, you know, so they didn't implement all the basic controls, and, you know, and probably no one wanted to rob them because there was nothing to rob. Okay, so that's what we do here, and we'll show you how it works. Okay, this is something that I think I'll just skip. It's just nice to show that we have a nice split here. The full implementers did more of the controls, but that's not really important. But the nice thing is the other variables split kind of equally, and that also helps us in the empirical estimation. So you can say we had a lot of luck, okay? Because if only 100 had done the implementation of the basic implementation of the directives, and 800 hadn't, or 900 hadn't, we'd be out of luck. On the other hand, if everyone said they implemented, we'd be out of luck too. And the fact that it's split like this leads me to believe that firms answer truthfully, because generally you want to say, oh, I did everything I was supposed to do. So we're pretty happy with that. This is something that's important for technical reasons, but I won't tell you. It just says this is a good instrument. Whether you implemented the basic controls or not, you know, if you implemented the basic controls, if you implemented the directives, get your brain working. If you implemented the directives, okay, then, you know, there's a strong correlation between that and whether you use the 6 basic controls or the number of basic controls you use. So that's really good. And that's again, another technical condition that has to be met. And here, I know this isn't really exciting for everyone, but I just want to point it out because it's really dramatic what happens here. If you don't take that into account, in other words, say I don't pay attention to whether firms implement or not, and I run a straight regression, okay, on incidents where firms had to do something to address it, they were attacked, they had to address it, and I do it as a function on all these variables. Notice that I do control, Moshe, for, you know, the targets, high revenue, large firm, high tech, high risk industries. There's some other things on the slide that you can't see. Cloud stuff, website, I control for all this stuff. They're all positive, and that just says firms that are, you know, good targets are good targets. But here, I get, on security measures, more security measures, more attacks, more incidents suffered. And this is, for those of you who understand statistics, this is a huge T statistic. This is 0.02 divided by 0.003. It's like 7 or 8 or something like that. And it's the wrong sign. Adding security precautions or using the basic ones does not increase the probability that you'll have to deal with an incident. Okay, so that's the naive regression. Here is where we're looking at using the number of controls as our security measure. Here, we're looking at those basic 6 controls, whether you did them or not. Notice the same kind of thing happens here. I get a positive and significant coefficient. The minute I run this instrumental variable regression, the coefficient flips signs, which is kind of remarkable given how positive this was, and it becomes statistically significant in a negative sense. That means that as firms use more security measures, other things being equal, you know, in advance, not as a reaction, okay, it's going to reduce the probability they'll suffer an incident. And that's true for both using basic controls and using the other controls. Okay, hopefully I won't trip on that thing. And so now I go back to the beginning just to give you the quick results. So, and then we can do the comparative statics, so to speak. We find that firms that used 18 out of 20 of the security precautions rather than 13, firms in general did 15, so we took the average. You can reduce the probability of an attack from 81% to 58%. Okay, that's not zero. But again, these are the largest firms, the firms that are the best targets. You know, they're going to suffer incidents. That's life. And the 6 basic controls are even better. And again, I think this is because it addresses the timing a little better. I'm really confident, I mean, because I can do it myself. I can implement those 6 basic controls in a day. So I'm pretty clear that firms that said they implemented directives were just in general. I'm sure that they had plenty of time in 2 years to implement those things. And here, again, you see that they reduce the incident of, probability of having to deal with an incident from 80 to 42%. So those are the main results. And without this question, which, they didn't think about it when they asked the question. I mean, we like to give them tons of credit, and they deserve tons of credit, but it was just lucky that there was a question like that. Now what we're doing, we're going to all the statistical agencies that we can find in the world. We're getting in contact with the UK, other countries in Europe, and well as the US, because we're wanting them to repeat this kind of thing, but this time to ask the question so we don't have to tease it out, ask whether the security precautions were implemented before or after suffering an attack. So I don't know if I lost everyone or if I was kind of boring, but I'm happy. I actually have a little time now because I only have to go see students. Well, don't record this actually. I'm happy to go see my students. It's live? Okay. Well, hopefully it's not interfering with the World Cup. That more people are watching that. Any questions anyone wants to ask?
Who are the recipients of this research?
What do you mean the recipients? What are we going to do with this paper? We're trying to publish it in the best economic journal there is. Okay, we've been giving seminars around the country, and I'm going to be giving seminars in the U.S. too. But the idea, to tell you the truth, again, off the record, I mean, I don't care that much about another publication. I want to do something useful. So part of what we're trying to do is get the other statistical agencies in other countries to do this, because this thing basically was viewed as insurmountable. Okay, this thing was viewed as insurmountable, but this is like proof of concept. It can work, and so therefore there's, and I'm doing probably some work which might turn into a grant with the Department of Defense related in the U.S. related to this as well. So I'm glad you asked that, because I'm more concerned about saving the world. I mean, well, maybe not saving the world, but saving the internet than I am. I mean, I would like to have a publication, but I can live without it. Any other questions? Yes.
As part of your study, are you taking into consideration the severity of the impact?
Well, that's a good question. The firms were supposed to report on the harms that occurred. But you know what? They have no clue as to how to do that. And very few firms answered that part. And again, the problem here was they didn't receive any helpful hints. For example, what's the biggest cost generally of suffering a cyber attack?
Loss of personal information.
Okay. Okay, what else? What's more important?
Bank accounts. Ransomware.
Well, think about firm. Not everyone. Forget about that. What else? Yeah, and what else? What is the most scarce resource we have? Time. It's time. And these firms lose time. And if you lose time and your website is down and things like that, but they never took that into account. All these other things need to be taken into account too. And we're helping them write the future survey in that way, because we would like to see what the harms were. We would really like to see what the harms were. And again, that's something that everyone kind of, just put up their hands and said it can't be done, and maybe they're right, but we're going to try to do it too. Okay, I talked too long, but thank you. My salad, okay, yeah. I have to eat on the way. Thank you very much, and enjoy the rest of the conference. Ta-da.
Okay, so thank you, Professor Neil Gandel, and enjoy your lecture. So I'm going to start officially by talking about the topic we're going to have at hand. My name is Aviv Sinai. I'm the R&D leader in a company called Taboola, and we're going to have a topic around digital solutions and resilience of a supply chain. Before Taboola, I served in a unit called Matzov, so I have some familiarity with some of the topics that we discussed here. And Abby graciously invited me to moderate this panel as someone from the industry that we have basically an R&D center a big one in LA, in Israel, and in Taiwan, close to 30 engineers focusing on AI located in Taipei. Taboola is the largest recommendation engine in the world. We see close to 500 million users a day. And our core technology, where basically what we invest in is AI, machine learning, NLP. And I can say I'm very excited to be here and seeing like all these lectures, because I think this forum talks about things that relate to policy and things that are very high up above. And eventually we there in the industry need to do things, I think, like on the ground. And I really liked the last lecture talking about the social studies, actually, because everything is people. And my ask here is that the scarcity of talent in AI, and I think one of the major things that we as an industry would love to have is better abilities to get that talent, whether from the US or from Taiwan or from Israel. And I can say that, for example, the X Talent program that's in Taiwan, or the previous one that was called LEAP, was amazing for us, and it basically built the basis for our AI teams in LA and in Taiwan. And so I'm very happy to be here, and I'm going to invite our next speaker, who would be Professor Ying Darlin from the National Chiao Tung University, who's going to talk about fueling cyber resilience in critical infrastructure and high-tech industry with open-layered ecosystem. Thank you.
Thank you. Okay, thank you. It's a pleasure to give a talk here on cyber resilience. And I'll be talking about from more an open ecosystem, how we could add multiple layers or multiple circle of trust. I myself is a professor in research university, and also I'm helping to run a new program called CCOE, Cybersecurity Center of Excellence. And okay, so there'll be three things I will talk today. One is the how we are doing the reorganization about the cybersecurity management in Taiwan. Yes? Okay, and the second thing is that what research and development work that we have been doing in CCOE. And well, it's a part, because CCOE is going to be a part of the new management. And so it's worth a while to take a deeper look into what kind of research we have been doing. And I would say that indeed AI play a major role here, that you could use AI to virtually many research problems. Okay, without AI, those problems could not be done automatically. Probably will be remain semi-manual or fully manual. The third one is, that I'm going to talk about is I try to look at the current ecosystem we have and see what's missing. And in fact, we still miss many circle of trust that are yet to be built, including the circle of trust between the industry, between the government and between the academia, or between each other, and also the international partners. That even though we have the intelligence sharing and also incident response, that information that have been shared internationally, but it's purely data sharing or intelligence sharing is not that much. I mean, it's not deep enough. So we need to build a deep enough circle of trust to facilitate deeper collaboration. So that's something I like to look for. Okay, and first of all, let me see the cybersecurity management in Taiwan. We are going to, within 2 months, we are going to have a new institute called NICS, National Institute of Cybersecurity, which will be merging two office or two programs. One is existing one, which is National Center of Cybersecurity Technology, which does management job mostly, and you can say that it serves as the front line defense in the national infrastructure, including the government sector and critical infrastructure. And the new CCOE program, which I'm helping to run, is more research and development oriented. And we are going to merge these two together to form the front line and the back line, so that we could do deeper understanding about these attacks and develop new methodology and tools. Many of them are AI-based, so that we could understand what happened right now in the battlefield. I mean, the cyberspace. Okay, and this is the structure of the existing center, that it handles, as you can see, that it handles instant response, and also it does testing and evaluation, and system or software security. These are the daily routine jobs that serve as the front line of the defense. Okay, and so they have SOC, ISAC, those kind of common structure that you will see in defense line. And the new center, CCOEs, would be mostly laboratory based. So you can see that we have a laboratory for cyber threat defense and cyber data analysis. So this is more like the cyber attack, and these are the attacks through the social network. So you can see that these are today information warfare is emerging. So disinformation. So this will deal with disinformation and defect. And then we have another lab called PQC, Post-Quantum Lab, and then the other program which are training and policy making. So with the NICS, we will handle 3 lines of defense from the first line, and the second line will do deeper investigation and forensics, and then the third line will be on research and development in order to provide better methodology and tool for the second line and the first line. And you can see that it will cover the government and the private sector, and except military. So military is another organization that handles that. Okay, so the second part is on research and development that CCOE has been doing. Certainly the reason why I'm talking about this is because, well, we know ICRC have been doing a lot of research, and so we certainly look for possible collaboration. So you can see from the cyber threat defense, we do vulnerability exploitation. So we do fuzzing, so some fuzzing methodology in order to exploit or mining the vulnerability in software system, in Windows and Linux-based or Android-based system. So that's the so essentially the output will be vulnerability identify, and some of them will be filed as CVE, as a standard CVE reported. And the other part is the threat intelligence platform, which will be cyber threat intelligence that share among the share internationally, so that you can identify where the actor group are, and what attack methodology they are using, and what tools or malware they are using. So these are the cyber intelligence threat platform, and you can see that for the vulnerability within less than 1 year, we reported 11 CVE officially, and there are some more coming up. I mean, these are not. These are some of these CVE vulnerability are identified by human engineers, but some are identified by the father, I mean the automatic father. Okay, and for CTI, cyber threat intelligence, it's well, I would say that it's a big search space that with the input of being IOC, the IOC could be the third-party IOC, where you want to look for the first party and the second party, where the first party is the attacker and the second party is the target. Okay, so you can see that from this, this input IOC is actually a C2 node. Okay, and from this we could identify that the first party, so this is the third party, and the first party is here, sorry, here. Attacking path is this, going up and down, and this is the second party, which is the target of attack. And you can see that it's a large search space, and how can you identify the attack path in such a large space? Essentially, you need an algorithm called node expansion, and you also need another algorithm called attack path finding. And if you use some heuristics based algorithm, for example, the severity, high severity first algorithm, then it's very possible that in the middle of the attack path, you will lose track, and then you will not be able to identify the attack path because some of the links are quite implicit, where their severity is not too high. Okay, so it's kind of losing the path if you rely on a single heuristic-based algorithm. So, but in our case, we find that using AI-based algorithm, because well, AI can utilize data with many different features, multiple features, then you could identify better the path without losing some potential links. Okay, which is much better than a single heuristics algorithm. So this is one example that that we could search in a large space, and this is another example that is a COVID strike that you can construct what happens and how the attack originates and what are the targets being attacked. And you can come up with the conclusion that these are game-based. Okay, they are attacking the game users. And similarly, if you look at the social network, it would have the same structure, that it's not a CTI connecting IOC, but it's connecting different accounts or connecting keywords used in the social network. So then you could still search the space in order to trace back who the bad guy is that launched the disinformation attack. Okay, so that's the same story here, that you could use AI to search in a large space of this big, and it gives you a pretty good result in identifying the path of propagation. Okay, the path of disinformation propagation. Okay, similarly, for defect, because you cannot rely on single feature. Well, it's full of AI, it's full of deep learning, and you would take a multiple feature in order to decide whether the video or the voice has been defect, and so you can see these are three applications that you can see where AI can play a major role in doing this kind of detection. Okay, other than that, we have PQC, which is where we have two members of the team have two proposals listed as finalists in the NIST competition for PQC, encryption and authentication. And then we have also a training program that train talents and young talents. And we are frequent winner in Black Hat in Las Vegas. Okay, the final message I want to deliver is we still missed multiple circle of trust. And because of time, I will just give a short overview. Well, this is one that compare just in this year alone, that you can see the attack happened in Israel and Taiwan and Ukraine. They have some similarity. Okay, so you can see that this similarity means that if one side, if these three countries they collaborated, then they could some other country might be able to identify the attack methodology earlier than when being attacked. Okay, so that's so there's a circle of trust to be built. I mean, we should build a circle of trust between these three countries so that we can have collaborative defense. And another example is that we have intelligence sharing among locally. These are local sharing and also globally with different entity in different countries. However, and also you can see that some statistics showing the amount of information being shared, the amount of intelligence being shared. But the thing is that they just share information. They don't really collaborate. They just pump the data to each other, and they are not actually doing a deep talk regarding what kind of attack model have you seen, and then we can exchange some our investigation results. Okay, if that kind of so I would say that the sharing is just the first line between first lines, but we need sharing between the second lines, which is at the forensics and investigation level. Okay, so that's another circle of trust to be built. Another one is you can see that because Taiwan has manufactured a lot of devices, ICT devices. Be aware that these devices might be infected. Okay, and when they got infected, it would affect not just Taiwan, but many countries that use these products. And certainly you would say that it's Taiwan's fault, but certainly these companies they are helping. They are trying to solve these vulnerability or infections as much as they could. But if there are collaboration across different countries, then they could solve these problems much more efficiently, and certainly that will benefit the user of these products. Okay, and the user of these products scattered around the entire world. Okay, so these are the CVE that happened on. You can see that 270 CVE on ICT product produced by Taiwan, and the vendors I know they are all busy to solve this, to reduce this, but if they could do more efficient if they get help from the allies. Okay, that's the final page. I would say that I'm delivering three messages. One is that we need three-layer defense line with incident response as the first line, and the second line being the investigation through CTI. And we also need a third line, which is research and development that back up the first line and second line so that they can defend better. And the second message is that, AI could be the default algorithm here in cybersecurity to solve the problem of like attack path traceback, social network traceback, and also defect detection. Okay, the third message I would like to deliver is the multiple circle of trust to be built still, because right now the intelligence sharing or incident response sharing is just very basic level. We need a deeper level of collaboration. Okay, that concludes my talk. Thank you very much.
Okay, thank you, Professor. I'm honored to invite our next speaker, Moshe, who's going to talk. Moshe Ferber, he's the chairman of the Cloud Security Alliance. He's going to talk about when technology innovation bumps law and regulations, and basically the complexity of software supply chain in our digital economy. Thank you.
Okay, so thank you very much. I'm the last speaker for today, so hopefully all of you will manage to last for the last couple of minutes, and I won't take long from you. I won't not be using slides in order for time's sake. My name is Moshe. In my private life, I'm part of the very vibrant startup scene that we have in Israel. I'm used to be an entrepreneur. Now, these days, I'm mostly managing my own investment in startup companies. But I'm here because I do a lot of research for the Cloud Security Alliance. The Cloud Security Alliance is a non-profit, non-government organization. We are based in three continents, in the United States, in the EU, in the APAC, and we produce best practices and research around cloud computing and help to secure this very, buzzword or major technology foundation. You can look at this in two different ways. And I'm here to talk about supply chain and digital economy, and the word supply chain is very big, so let's try to narrow this into what I want to talk about. Let's talk about the shoe manufacturer in APAC, or law firm in the EU, or graphic designer in Israel, when they start their own digital transformation journey, when they, talk to the mic, okay, maybe. Like Professor Neil, maybe I use the mobile one. Will that work? So, thinking about small, medium business, trying to make his own digital journey, trying to make digital transformation. He's now building his online presence. He will probably using a lot of different software vendors. Some of them will host his online store. Some of that will host his customer relationship model. Some will host his, his warehouse supplies. So he has very different vendors in a large ecosystem to rely on. We call them software as a service vendors, and we have thousands of software as a service vendors. There is no market gaps here. There's a lot of vendors from different geographic locations. Some of them are very mature, and some of them are very large. Some of them are smaller and produce smaller footprints, maybe even less secure services, but we have the variety, we have the option to choose. But this comes with, always there's a but, we have this big, vibrant startup, SaaS software as a service scene, a lot of companies, but they are all sitting on very few numbers of infrastructure and platform as a service providers. So think about this like a reverse pyramid, like upside down. I'm trying to do with my arms, it's hard with the mic. But again, so many vendors will all have their data located on a very close number of infrastructure vendors. Gartner talks about 7 hyperscale providers. Let's assume it's not 7. Let's assume it's 20. It is still a very definite and small number of providers. And why is that important? Why is the challenge in that? Those providers are now turning to be the Port Knox of the digital era. We say that the data is the new gold, so they are hosting most of the humanity data. It's true that we have different providers in the APAC, in the EU, in the United States. The Western world is using mostly Google, Amazon, Microsoft. In China, in India, and the APAC, we have different providers. But in the end, most of the data that we produce ends up in the hands of 10, 20, 30 providers. And this is a challenge. And why is that? Why is that a challenge? I can think about 3 scenarios. First of all, it makes those companies very, very strong. I'm putting this aside. This is another debate that we need to think about. And the United States already began trying to break those companies into smaller chunks, putting it aside. Second, it makes those companies a target for cyber criminals, and it makes sense. Again, most of the knowledge is here. Taking down one provider like this is a lot of, there's a lot of price to that, there's a lot of benefits to that. But again, I'm putting this also aside because those companies, those infrastructure providers are usually large enough and they're professional enough in order to cope with most of the cyber incidents in the private market. But there's another side to that. There's another challenge. This is what I want to talk about to you these days. Because those companies are hosting most of the humanity knowledge these days, they become a target for government access. And different governments all over the world are looking either officially or non-officially into how to get their access to this different private sector data that is stored in different in very few locations around the world. And this is the challenge that we need to cope with. We've seen lately there's been the trial of, there's been in the trials around Twitter, we saw that 5 evidence of different government agents that were intentionally hired by Twitter from different governments just to make sure that they have good relationship with the hosting government. And this can be also be found in other cloud providers, but we still haven't seen this in court, in evidence, but we know this happens. Now, this could be either espionage, somebody goes into the server room and pulls out a disk with the data, or this could be a very organized government access to data by court orders and subpoenas. It doesn't really matter. The result of this, by the way, I'm putting government access in one place and also the privacy laws around the world that also make the personal data very important. What is the effect on that? Because governments want to access data, because governments and different intelligence organizations are accessing data, we see more and more countries adopt practices of data localization. We see this in privacy laws. GDPR, for instance, in Europe, you cannot move data from the EU outside. Similar laws exist in Australia, Brazil, India, and very other places. And we also see this with government data, okay? Many governments are saying, okay, well, I'm not going to host my data outside of my country, outside of my jurisdiction, outside of my geographic boundaries. And where do we meet this? What is the challenge of this? First of all, for the private sector, for the startups, which is where I'm coming from. Currently, this time of the digital era, if I want to address both the American market and the EU market, I need to build 2 different data centers. I need to operate in 2 different locations. So one in the United States, one in the EU. And if I want to address the Indian market or the Chinese market or the Australian market, I need to build another data center and another data center, another data center. And this is a barrier for innovation because, again, I'm a young company. I want to produce innovative services, and I need to every time I need to go approach a different market, I need to double my efforts. I need to replicate what I'm doing. And this is one barrier for innovation, and this is a challenge for the private market. And why is that a problem? And again, young companies don't have the capabilities of building this operation. And it's counterintuitive to everything we know about the internet, right? The internet was built in order to connect people. So cloud computing allows me to launch workloads on the other side of the world from my iPad. But laws, regulation, government access, and the worries that, and all of the concerns that arise from that makes me still work in my own geographic location and not use this technology. The second challenge is for the governments. Okay, so in Israel, we just finished a very large tender, but the government was busy like 4 years creating it. It's called Nimbus, and the entire goal of this tender was to bring 2 large cloud providers into Israel. We're still using foreign providers, but they are still able to. We are still able to make them build their own data center here in Israel, so it will be under our jurisdiction. So we solved some of the data localization challenges, but what about smaller countries that cannot do this? That cannot issue a large tender and make one of those cloud providers in their own jurisdiction. So their innovation is being held. They're not able to adopt digital services, or they need to rely on some foreign ground data centers, the same way as smaller countries have been using oil and other resources from the large companies, and we know how this is changing the world geopolitical situation. In the next couple of years, you see more and more countries rely on compute and data resources from different countries, and again, this will increase increase their dependencies on other nations, on the large nation. And again, this is a challenge for innovation, this is a challenge for the digital transformation, this is a challenge for the entire digital community. So this is the challenge that I'm presenting. How do we create both the technical measures and also the political and laws and different frameworks that allows us to cooperate with each other? With privacy laws, we're slowly moving into some kind of a global framework. GDPR was leading the way. Other countries adopt similar stuff like GDPR, so we can now maybe create a framework. But that's only for personal data, and governments and private companies hold very different types of data. Some of them are not under privacy laws. And again, we need to set up, from the laws and regulation, we need to set up kind of a framework, who can access which data on which jurisdiction. From the technical point of view, we need to increase our data protection mechanism and mostly invent in new encryption mechanism like confidential computing or homomorphic encryptions, which enables me to store my data on somebody else's jurisdiction, not providing them access, but still do compute on this encrypted data. So again, two spearheads, very different in nature, laws and regulation and frameworks of different countries agreeing to safely guard the data, and new technologies that will allow us to compute on encrypted data and store our data in an unsafe location with some kind of an assurance. Thank you very much.
Thank you, Moshe. I want to invite the previous speakers. We're going to have a quick Q&A panel. And instead of Professor Gendel, we're going to have Deputy Director General Joe Xiaolin join us. Thank you. So I know we're a bit late, so I'm going to try and have it to be quick. My first question I wanted to ask each and every one of you. So everyone knows about cybersecurity, something that Israel is known for in all the other countries, and it requires a lot of resources, and it requires also top management a commitment to putting these resources, whether in a private company or like in a national or in a country. And I'm wondering if you have any advice, or how would you draw their attention to investing in cybersecurity, and even more specifically in supply chain, which is actually outside usually what you invest directly. And to add on that, the looming recession and inflation and everything that's going on makes it even harder to do that.
Okay, you go first.
Moshe, you go first.
I go first. Okay, so that's a big challenge, yeah, and we're not going to solve this in one location. First of all, I want to address the role of the governments. Governments can be a regulator, which can force us to do stuff. They also operate. They hold big chunks of the data. They are also promoter. They promote innovation. Some of the governments at least try to do so. So I want to see the government do less regulation and let the promotion of the innovation inside the market. And this is like a general comment for that. But what they do need to do as regulator is to make sure that the fines are well enforced. And we saw that this made a big difference in GDPR and privacy. Once the fines have been raised into a certain bar, we see more and more companies are adopting and starting to adopt new way of thinking regarding privacy laws. So we need to adopt this framework again. But I want to say again, government should should very narrow its regulation efforts, but make sure that let the private market do their own risk assessment. But make sure that if you blow it. If you don't do proper risk management, then the punishment will be wide enough. Currently, most governments they concentrate on doing regulation, providing guidelines, but less about the enforcement side point of view.
Professor, let me add one comment. Yes, well, but we still see some different countries enforce different degree of regulation. For example, in Japan, I saw that well, the regulation is quite strong. That well, there's a sudden jump on the market, I mean, the cybersecurity market, due to that regulation, and they really means that kind of I mean reinforcement on about the regulation. That happened in Japan, but that didn't happen in Taiwan because well, the regulation is kind of soft, not hard, not as hard as Japan. Instead, because it really depends on whether the government is brave enough to fight back about the opponent. Okay, and well, in Taiwan it's well, very democratic. So you need to take it soft instead of hard. What can be done, and as I mentioned earlier, that there are alliance among the high-tech companies. We actually, well, TWCERT actually formed an alliance for the high-tech companies. And you know why they, and most high-tech companies, they join. You know why? Because they join so that they can be aware who have been, what kind of attack model has been prevailing, and they can take precaution so that they can prevent the same thing to them. And that helped a lot because, well, everybody, because we are in the same community and we suffer the same headache. And you got a cure, or you got the incident, and you got a cure. So then if I know it, then I can take precaution so that I won't be infected. So that helped a lot. And I think that's something soft, and it could be done. You build that kind of circle of trust, but you need to be aware of the size of that community. It couldn't be too big. For example, if you put different type of company in the same community, that doesn't help, because if we are in different industry or in different, for example, you are the high-tech company, I'm the critical infrastructure company. Well, your problem might not be mine, but so I should form an alliance with the one of a kind. So you are also a critical infrastructure provider. I'm also, so I should build the community with you. So the size of the community or the member of the community matter. Okay, thank you.
Thank you.
Okay. I think I agree with the two panelists' comment, and the regulation is the most effective way to, sort of draw owners' attention to put more resources in cybersecurity. In Taiwan, actually, a lot of company is family-run company, so owner is the decision maker. So you have to draw owners' attention. How to draw owners' attention? Yes, regulation is in Taiwan. I have two examples for you. The first is the Financial Supervisory Commission of Taiwan. Is require all public listed companies to set up a chief officer of cybersecurity, and those public listed companies has to report major cyber attack incidents on their website. I think this will draw owners' attention. And another example is the National Science and Technology Council in Taiwan requires all government-funded projects to allocate up to 7% of IT budget on cybersecurity preparation. So I think those regulations will draw owners' attention. Yep.
Thank you. Very interesting. I think we have time for one more, right? One question. And this question, actually, I want to talk about more about AI. I think it was shown throughout the day as something that is, of course, a technology that is used throughout the industry and also in cyber. I'm curious, from your standpoint, looking into AI, what are the most prominent problems that AI can help solve? You've mentioned in your talk. Also eager to hear others. Moshe?
Okay.
And if I can add, and what can't they solve? What they cannot solve as well.
Okay. Yeah. Okay. Well, you shouldn't apply AI on all kind of problems. For problems that are the input is very well defined, you shouldn't. Well, the input data is very well defined, and well, the procedure is very well defined. Then, well, you can solve with the traditional algorithms. But if the input is not well defined, and sometimes the input data are missing, and the input data is too big, okay, then well, that's where AI can play a role, because well, which means that the compressity or the completeness of the data is not the compressor is too big, or the completeness is not enough. Then well, AI tend to solve better. The reason is because well, you have better kind of fault tolerance in handling missing data, and also you have ability to explore in a large problem space. Well, especially when you have many different features that you could that could affect your decision, and well, because of these features, that you probably don't know in advance which feature matters and which don't. Then AI would explore for you, and that's the power of AI. You want to add a few?
Just a couple of words. I'll take the devil advocate approach here to this. I see a lot of startups building something that they call AI or machine learning or whatever you want to call it. I haven't seen something that really blown my mind away. I mean, I think AI and machine learning will be another tool in our toolbox. And the reason why this innovation is not moving that much forward is, first of all, is the data sets. Okay, so as was mentioned here just now, in most cases, we don't have the right data in order to feed the AI mechanism. So for online transaction, yeah, we have good AIs that can distinguish between bad transaction and the worst transaction. But for regular law firm or a plant, I don't know, a shoe manufacturer, they simply don't have the data to make sure that the AI models will work. So first of all, the industry needs to work better on producing data sets that are actionable. And from that moment on, the machine learning process or the AI question will be much easier in that terms. With that said, AI can definitely help us sorting out huge chunks of data that we were not able to do so. It's also helping the bad guys sorting out bad chunks of data that they were not able to do so. So we're pretty much equivalent here. They move faster. So we are running out of time here. So again, we need to think about how to produce better data for our AI models.
Okay. There are a lot of open source, modules in terms of AI machine learning. I use this open source to recognize species, plant species. So I think that's we can call it transfer learning. Okay. So you need this data, and you just use the open source module to recognize, to do whatever you want to do. And in this stage, the most mature technology in AI is visual recognition and natural language. And yes, in Taiwan, a lot of companies use this technology to help their business. So I think visual recognition and natural language is very good, and its technology is mature enough to allow companies to use. Yes.
Okay, thank you. So we actually have 10 questions, but we won't continue to ask them. I know we're out of time. I want to thank the speakers here for very interesting talks, and thank you all.
Great. So I want to thank all the speakers, and I think that we have passed here a few hours that really covered so interesting questions, topics, and we heard different perspectives from all our participants. From my standpoint, I want to thank all the people that contribute to this session. And as we started before the two sessions, and we asked Professor Ben Israel to give us his perspective, so we'll invite Professor to conclude this day. So Itzik, please.
I realize I'm the only barrier between you and lunch, so it will be very short. Few remarks, okay, because we covered too many topics. One, we speak here about digital economy. The word digital is central here, and we live in a digital world. And usually, because it is digital, we tend to think in terms of 1 or 0, white and black, true or false, and which doesn't really fit life. Life is much more complex than this. Perhaps when we have qubits instead of bits, the machines will also be capable of simulating what is really happening in life. Now, this is not just a saying, because the main issue, and I think it surfaced here, main issue that we have to bear in mind is that it's not only when we speak about digital economy or cybersecurity or AI or God knows what, it's not only about pure technology. I mean, there are other aspects which are not measurable as the technology, like legal problems, social behavior, different conflict between attitudes. And it was demonstrated, by the way, by Professor Gal Ostrich, which I don't see her. There are so many aspects that if you don't really take them into account, you don't understand the problem. The problem, I mean, we live in the 21st century. We tend to solve any problem by technology. This is our century. But we have to bear in mind that the problem is not technological. Problem rises from human nature, human problems. The solutions are technological. So if you don't take into account those softer aspects, I would say, okay, you don't really understand the problem, you may come with wrong solutions. This is one message. And another one is about, I mean, we have here representatives from 3 different communities: industry, academy, and government, generally speaking. The relationship between these 3 is also has to be deeply understood. Okay? It's not so simple. When we speak about new ideas, breakthrough technologies like we do here in digital world, usually this is a process that comes from bottom up. Okay? I hate to say it, but the younger you are, the better chances you have to do something. Okay? It's a process that comes from bottom up. And therefore, many people say, well, the government cannot sit somewhere on the top and decide that this idea is good, this idea is not good, or something like this. It's a process that should be the other way around. But it doesn't mean, this is a mistake, that the government doesn't have a role here. Okay? So when I first started to read Paul Romer, as I told you, I mean, he said that technology is developed by a human being, and therefore education, young generation, etc., play much bigger role in economy than production lines and things like this. And people understood him as if he claims that the government should step aside and let the free market do whatever it does. It's not true. The government can encourage this or suppress this process. Okay, I hope not suppressing, but encouraging. And this is what we understood some 10 years ago here in Israel, started certain, I would call it encouragement processes, okay, something like this, to let this process develop. Otherwise, the government can cause a lot of problems. The last thing is a story, a short story, 2 minutes. I told you that in 2010 I was called to the Prime Minister. At the end of it, I found myself appointed to lead this task force that initiated the cyber revolution here in Israel. When he called me at the beginning, he had a narrower task in his mind. Okay, so I tried to convince him that we should take care of the whole ecosystem, including the non-defense, non-military parts of it, especially this. And it was, I remember the minute in which the light hit him in a way, and he understood it, and this happened after we had some discussion, and then he said, okay, we will continue it in 4 days because I have to go to Europe, some country in Europe. And I told him, I'll give you a book to read in flight. A fiction, not a book about the theory of this or that, but some fiction written by a French author. And I gave him the book. The book tells a story. The year is 2010, okay? The book tells a story about one superpower that has a problem with a smaller country, and then they decide to do something against this country to show that they are serious, and they consider all the options, decide to do something in what nowadays we will call cyber space, okay? Put some malware, some virus, etc., and they lose control of it, and it spreads and hit other countries. And the end of the book, it ends with almost a Third World War just starting. And he read the book, he came back from the flight, and he said, okay, I'm now convinced we will launch the overall cyber program. The book was written by a French author. It's called Babylon Zero Minute, first minute or 0 minute. And I guess you didn't read it because as far as I know, it was translated only into Hebrew. The author is someone from here, only into Hebrew. And the superpower is China, and the small country is Taiwan. So you have a bigger role in Israeli cyber development than you think. Thank you very much. There are a lot of things we should do in all those three, industry to industry, academy to academy, and government to government levels, and we will do it. Thank you. Bye.